one the one that in front of the seaside. While in Legon Kulon Subang, the government put rock armors on the beach approximately 3 kilometers to harden the coast and to make the beach more resistant. And the local people put sandbag behind the structure to trap the sediment and to heighten the land surface. However, the seawater still can penetrate the settlement through the canals and unprotected coast. A set of preliminary engineering measures in conjunction with the sediment management scheme is proposed as adaptation strategies. The channeling of the river and or reopening the old Citarum Creek is one option available to obtain the sediment supply to the degraded area. So it will become a natural reclamation to compensate the natural sediment compaction in the degraded area. The adaptation strategies are also applicable in Legon Kulon Subang, with the channeling of the Cipunaga River to the degraded area, or reopening the old Cipunaga River to obtain the sediment supply to the degraded area. The mouth of the Cipunaga River was in the north before it diverted in 1980s to the east and formed the new Cipunaga Delta in the east. These are the sediment managing scheme. In the early stage, the traditional breakwater or sediment trap is installed in front of the current shoreline, about 500 meters to 1,000 meters. And on the next stage, once sediment accumulated behind the structure, mangrove planting is recommended to promote the sedimentation processes and coastal progradation. In the long-term approach, some more sustainable and resilient measures are proposed to mitigate and largely stop the impacts of subsidence, including first, restriction of groundwater extraction for counteracting human-induced subsidence. Second, natural and artificial recharge of aquifers for speeding up recovery as well as control the aquifer storage. Third, development of alternative water supply instead of groundwater for industry as well as domestic users. Fourth, integrated floodwater management strategy. Fifth, improving governance and decision-making by enhancing technical, administrative, and institutional capabilities. Sixth, appropriate monitoring and database system. And seventh, integration of geotechnical aspects in planning and design of building and infrastructure. In conclusion, first, land subsidence is a slow onset disaster that may increase coastal inundation and other detrimental impacts, but is frequently slowly detected and realized. Second, land subsidence and coastal inundation occur in Muara Gembong Bekasi and Legon Kulon Subang have induced the loss of land up to more than 1,000 hectares and 700 hectares respectively since 2000. A combination of long-term behavior of oceanographic variables such as extreme waves and sea level rise in coincidence with high subsidence rates is responsible for the increased flooding risk in the coastal region. Fourth, subsidence in low-lying coasts and delta environment such as in Muara Gembong and Legon Kulon is not merely caused by the anthropogenic factors such as groundwater overpumping, but is involved complex technical aspects including natural sediment compaction and less sediment supply. Fifth, a set of preliminary engineering measures in conjunction with sediment managing team is proposed as adaptation strategies. And 6, more sustainable and resilient measures are proposed to mitigate the impact of subsidence, including urban groundwater and flood risk management, as well as strategic spatial planning. Thank you.
Yeah. Okay. Thank you very much from video from Mr. Tubagus Solihuddin. So we have 3 minutes for a discussion session. So if anybody have a question regarding the topics, you can unmute your mic, or maybe you can write the question through the chat room. Thank you. Please. Is there any question from everyone? Yeah, yeah.
Good afternoon. My name is Yari Karamawati. Can you hear my voice?
Yes, please.
Okay, I want to ask to Mr. Tubagus about his presentation. It was a great presentation about land subsidence. Actually, I want to ask about this slide. Mr. Tubagus said about the sand characteristic, the sediment characteristic of mud and sand. It is impactful to the land subsidence. How far the mud and sand impactful for the land subsidence in your area research? Thank you.
Can I? Excuse me.
Okay. So my question is, in the slide that in the picture of your PPT, I don't remember which page is it, but you present the coastline. It consists of mud and then sand coastline. So how far the impact of sediment size and sediment characteristic to the land subsidence in that area?
Yes. Okay. Thank you for your question. So it significantly impact the land subsidence. I mean the sediment characteristic. If you notice from my presentation, both areas, including Muara Gembong Bekasi and Legon Kulon Subang, are characterized by muddy coast. So it has low resistance to compaction, sediment natural compaction, and also to the eroding from the wave, both from wave and current. So the coastal characteristic and sediment characteristic is significantly influenced by the land. Land subsidence is significantly influenced by the coastal characteristic and sediment characteristic. Okay. Is that answer your question? Sorry. Any more question? Or
thank you.
Okay.
Okay, thank you for the question. Is there any more question?
I have a question for Mr. Tubagus.
Please.
So in the title, you write that coastal inundation and land subsidence in north coast of West Java, a new hazard and question mark. And why did you put new hazard? Is this a recent phenomena? It never occurred before. And if it's so, then what do you think the driving force that can make this coastal inundation and land subsidence that recently occurred in your study area? Thank you.
Okay, thank you, Amanda, for your question. So, why I put the question mark in my title of presentation? Because north coast of West Java has limited monitoring data and risk mapping so far, because everyone researcher only focus on Jakarta and also the other area in Central Java, such as Pekalongan, Demak, and Semarang. So the land subsidence and coastal inundation in the north coast of West Java, ironically have less paid attention. So I put the question mark like as so to raise the awareness of us that land subsidence and coastal inundation also occur in north coast of West Java. That's the first thing. And the second question: what is the major drivers of the land subsidence and coastal inundation in both areas? So in the conclusion, I said that this is a combination, not a single factor. This is a combination of the long-term oceanographic variables such as extreme wave and sea level rise due to climate change, and the high subsidence rates in both areas. But unfortunately, we have so far very limited accurate measuring techniques about land subsidence rates in both area. So we just determine the land subsidence in both areas based on ground observation and looking at the damage and the increased flooding in both areas. So the determination of land subsidence rates in both areas is still underway. Thank you. Is that answer your question, Amanda?
Yeah, thank you.
Okay, thank you very much for the question. So, but unfortunately, our discussion session is finished. So, we would like to say thank you for Mr. Tubagus Solihuddin for the presentation. It's very nice presentation. So, yeah. Okay, we will move on into the next presenter. Yeah, however, I see from the participant list, our invited speaker, Professor Xiao Hua Wang, haven't attend our room yet. So we will move on into the next presenter is Mr. Fajar Yudi Prabawa. So, however, we haven't received any video from Mr. Fajar, so maybe you can present your presentation in the live. Okay, time is yours. Thank you. Yeah, for reminder, please, the time limit for your presentation is 12 minutes.
Thank you very much, Mr. Hanif, for place and time, and everybody. greeting for me and my teams. Allow me to introduce. I'm working as a researcher at the Ministry of Marine Affairs, Jakarta. Directly, the location of the research is close to Jakarta, on the border of West Java. It's in a Muara Gembong district, but different from the previous research location. This part of location took place at the western part of Muara Gembong. It means it is inside the Jakarta Bay. So the problem is the abrasions that hitting Muara Gembong districts, especially in Sederhana Beach, is already existing for decades. And last 2 years, the government had constructed a plan to build and to conserve that location by stating a plan for the integrated coastal zone management. But many problems still exist that canceling many programs there, including the strong of the abrasion. And before imply the plan of the ICZM on location, it is needed to mitigate them first. So how to mitigate the coastal hazard, especially the abrasion in research location? So the aim is to mapping the abrasion components. We use the methodology of sedimentology approach by determine the type of sediments, sediment distribution, and its depositional environment. Then after that, those data could be classified and be analyzed to proceed to stage synthesis to assume the research results. The data collections were used the primary source from grab sampling, as well the observation and documentation, and it's backed up by secondary data reference study. Then the analysis we use exactly the hybrid qualitative and quantitative descriptive analytic. Then finally, the working result is assuming the recommendation for mitigation. This study location has 37 stations. The measurement, which was the measurement of the bathymetry, we did that, and of course the grab sampling. So the focus outcomes is the sediment types and its distribution, also type and direction of seawater that presume from the condition of the sediments. We need to know what the type of seawater that controlling the abrasion, what the primary agent of seawater, which is a wave or current. And then the last is to mitigate the anticipating abrasion. This is the result of the sediment plot. Please, the red note is just only waypoint. This is not a lithology. The sediment lithology we had the four type of lithology, which are coarse and fine sands, which symbolized by the yellow dots, and the clay symbolized by the brown, and the silt symbolized by green. So this is the plotting of zones. We can see 75% of sediment in research locations covered by clay. It is normal because there are many estuaries there, and most of them passing the floodplains that 40% of them covering the Muara Gembong geological lithology. So they supply the sediments of clay in research location. And then the interesting one, we plot the grab sampling, the zone of coarse and fine sand, which is accumulated in one zone, one long zone inside the clay zone. We can see from this map the sands lithological sediment is breaking out the clay zones, and it contacted directly to the shoreline, which is the domain of the mangroves area, especially at the north. So the existence of the coarse sands inside the clay area and contacting the mangroves area is a strong indication that there is a longshore current. So we have a proof that the main agent of seawater that working, hitting and uprooting the mangrove tree there hardly is the longshore current, stronger than the wave. This is the abrasion zone took from the documentation to fortify our evidence. And then we plot the mitigation zones. We divide into 3 zones to work on with the mitigation zones.
Sorry, Mr. Fajar, 5 more minutes.
Okay, thank you. Then our recommendations for the mitigation is to establish beach structures. The beach structures which is fit to the problems in research locations, we have analyzed them, are the groins and jetties, because they are perpendicular to shoreline. And combined with the bulkheads or seawall, but it is recommended just the bulkhead, just simple bulkhead from bamboo and wooden. Why jetties and groin perpendicular structure? Because they can block the longshore current, and in the same time they can collect the sands to becoming the accretion. And the last combination of the mitigation recommendation is the plantation of the mangrove. So the conclusion is resource location is severely trapped by abrasion. Prime agent of the seawater that working the triggering the abrasion is longshore current, northeast to southwest. Mitigations divided on 3 zones. The recommended mitigations is to establish beach structures, groins and jetty combined with bulkheads and mangrove plantation. Thank you very much.
Okay, thank you very much, Mr. Fajar, for the presentation. It's quite very nice presentation. So yeah, we will have a discussion session. The time limit also same with the previous session is only 3 minutes. So anybody have a question, please just unmute your mic. Thank you. Hello, Dr. Fajar. Hello,
Yeah, hello?
can you hear me?
Yes, I can hear you, but little voice.
Oh, all right, all right. Mr. Fajar, why you choose that location instead the other location? Because I think the location is little bit coverage, I think.
Oh, thank you, Mr. Lutfi. This location is interesting for us because perhaps there is some a bit similarity to the reason of the previous presentation concerning the same location, Muara Gembong. It is the closest area to Jakarta, but it has very low lack of data, especially on the sedimentation or hazard. So I think this is interesting because from 2018, we analyzed the pattern of the sediment loss or land loss in the research location. It is very severe. The research location experienced very grave abrasion. One paper mentioned it has only 15-meter loss of land per year. The other mentioned 40. The other one, 200 meters. And by the interview with some of the local people, even there is a possibility some spot has the land loss around 500 meters. So it is interesting. Opposite of that, this location is part of Jakarta Bay, the eastern part. In the RTRW, the master plan of Jakarta Bay, this location would be built in a big scale. So it is irony. The government plot the draft of the big development in Muara Gembong, but the same time there is no effort to mitigate them from losing land more. Thank you, Mr. Lutfi.
You're welcome, sir. Maybe one more. Did your research have the you mentioned about the sediment loss? Maybe you, this publication have the how many the sediment loss that happen in that area?
At least there are 3 publications mentioned about sediment loss, but all of them has the subject of GIS. So they calculate the estimate the sediment loss just from above the air. That's not quite valid for me. So we need to do some sampling there, some measurement on site, on location, whether it is on water and on the shoreline, and also on the terrestrial. But we map.
How many maybe publication using the remote sensing like for it?
At least 3.
3.
Yeah, At least three.
All right, got it.
3 or 4.
Thank you, Dr. Fajar.
Thank you, Mr. Lutfi.
Okay, thank you for the question. So maybe we have one more question. Yeah. Okay, if there's no question anymore, I would like to say thank you very much for Mr. Fajar for the presentation. Very nice presentation.
Thank you.
So okay, we will continue to our next presenter. Our next presenter is Miss Hilda Arifiana. So maybe we can, yeah, we can play the video, please.
Hello, ladies and gentlemen. My name is Hilda Arifiana. I'm a master's student from Shunkunukan University. In this good occasion, I would like to explain about my paper. The title is The Shoreline Deformation in Convex Dish Due to the Sea Level Rise. And then the next slide. Hello, ladies and gentlemen. My name is Hilda Arifiana. I'm a master's student from Shunkunukan University. In this good occasion, I would like to explain about my paper. The title is The Shoreline Deformation in Convex Dish Due to the Sea Level Rise. And then the next slide. So this is the outline for today's presentation. Okay, this section is the background of my paper. This graph shows the cumulative change in the sea level rise for the world's ocean since 1880 based on a combination of long-term gauge measurement and recent satellite measurement. This figure shows average absolute sea level change, which are equal to the head of the ocean surface, regardless of where the land is rising and falling. The ocean floor has been gradually sinking since the last ice age 2,000 years ago. In addition to the global average sea level rise, local sea level rise, sometimes called relative sea level rise, happen at different rates in the different places. Local sea level rise is not only affected by the global sea level rise, but also by local land motion and the effect of tides, current, and wind. There is so many cities have been affected by sea level rise. For example, in Indonesia, the Indonesian capital Jakarta, around 10 million people and is built on low-lying land to the next sea. And then in the past few decades and now with a population of 28 million in the Shanghai is another sinker. The city has maximum subsidence rate of around 2.5 centimeter of year. Again, this is mostly caused by water levels. For another example is New Orleans. In New Orleans, embankments and beaches have effectively drained the city and sunk it, leaving half of it below the sea level rise. In Indonesia, the center of economic activity are mostly located in the coastal cities such as Jakarta, Surabaya, Makassar, and so on. Indonesia is expected to be severely impacted by global sea level rise as well as accidents. The dominant impact will be felt by people living in coastal environment. The use of satellite altimetry to predict the trends of sea level rise in Indonesia reveal that Indonesia's average rate is higher than the global average. Through data from Poseidon and JSON 1 until 3 altimetry satellites, it is estimated that Indonesia has sea level rise up to 3.9 millimeter per year between 1992 and 2020. In this part, I will explain why I choose the convex base to my study area. It's because the most of the convex base are business or development for tourism. So my client offers activities were built around, for example, in this island. And then for other examples is the sandy beach of the Grand Strand in the northeastern South Carolina. Sea level rise will have important socio-economic impact of the convex beach of the province. I mean, from the study mentioned, it can be concluded that sea level rise is influential on coastal communities, especially convex beach, which mostly obey the economy tourism. That if the coast decline, the impact will be bad if not handled properly. In the part of literature review, there are so many studies that apply relationship between sea level rise and the salinization for the concept of equilibrium geometry and sediment conservation as introduced by Professor Bun in 1962 on the basis of the assumption of the Bohr model derive the basic of relationship for predicting the horizontal relationship of the shoreline R from an increase in sea level rise as and then this is the equation where we start is with of the active profile to the depth h and B is the head of the berm. However, one restriction of the berm rule is the sea level rise should be much less than the berm height. So in 1972, Professor Edelman removed this limitation of relative small change in sea level rise by accounting the progressive decrease in relative elevation. In the other years, Professor Bun at the profile slope of the active profile in his equation. So this is the new equation from Professor Bun, where tan theta is the profile slope over the active profile. So the study that I have mentioned before is the separate study get the shoreline change due to sea level rise from a lateral view. Rather than approaching variability from sediment transport or morphological point of view, it indirectly examines the deformation of the wave baseline through the wave deformation model. In this section, I will explain about wave deformation model. The wave deformation model include two input model. The first is the depth input model, and the second one is wave parameter. For the depth input model, we use a sand beach phase and a Rossel area. For the beach phase, we using the concept of equilibrium beach profile. We use depth 4 meter in the accent of the sea level rise. And then this is the equation where S is the water depth at the distance of Y, and then A is the big scale factor. For the soil area, to simulate the formation of a convex coastline due to the influence of the underwater topography, rather along all under the reef was applying along the beach as shown in the equation below, where x0 and y0 are located in 500 meter and 200 meter, which are the center of computational domain as shown below. By comparing the beach phase and SER water depth, the lower water depth was selected as shown in the figure below. And then illustrated figure corresponds the current water depth when no sea level rise has occurred. So this is a numerical element. Uh, A is for 3D view, and B is the side view, and C is the depth counter, and D the result from wave deformation model with the sea level rise. The wave deformation model, or WDM, uses the Mills-Slope equation of hyperbolic type as the governing equation. The dispersive character of propagating wave is contained in the dispersion relation. The linear governing equation of the wave numerical model is a Mills-Slope equation, and the representative nonlinear governing equation is the Brusninsky equation. And then this is the equation for Mills-Slope equation of the hyperbolic type, where eta xy is the complex value amplitude of the free surface elevation zeta xyz in the horizontal position, and then del point is the divergent operator, and then del the horizontal gradient operator, and Cp and Cg are the local phase and the group velocity. For the model scenario, we conduct for scenario in this paper. The applied incident wave condition was applied with a wave height of 105 meter and a period of 5 seconds, which is considered to be a normal wave height. The difference is only for SLR. For scenario A, SLR is 1.5 meter, and for scenario B, SLR is 1 meter, and then for scenario C, SLR is 1.5 meter, and then for scenario D, SLR is 2 meter. Then we have the result and discussion for this model. The results obtained by applying the wave deformation model are shown in the figure 7. The coastline forming the breaching wave with respect the current normal wave at the both ends where the coastline is not affected by SIR, a region of 23 meters. In this case, assuming that the beach surface area is preserved, less erosion occurs than the case of the open end. That is, the sea level rise of 1 meter causes the erosion of 6.3 meter in the convex area, but the shoreline advance of 3.9 meter at both ends. And if the sea level rise of 2 meter occur, the erosion of 14.3 meter can occur in the convex area, and shoreline advance of 8.6 meter can occur at both ends. Finally, this is the last part of this presentation. We have for conclusion for our paper. The first is the result of the wave model examining the change of coastline according to sea level rise, so that as the level rise rises, the refraction of the main wave is elevated and the coastline can become flatter. In addition to shoreline retreat due to the change in the cross section of urban, it can be seen that the convex topography is more vulnerable area for future beach erosion. As such, in the current beach, there is convex by topographical influence such as coral reef and rock below the water surface. It is necessary to examine the rate of the shoreline retreat at this type of shore in advance because serious erosion damage occur in the future. The result of this model is an early study on the erosion vulnerability of the convex coast. And in order to derive more reliable result, it is required to directly numerically analyze the effect by combining the wave model and the coastline or isocenter model combined with the wave model. Okay, thank you for attention. If any question related to my paper, you can contact me through this email.
Okay, thank you very much, Miss Filda Arifiana, for the presentation. So we come to the discussion session. So is anybody have a question? Just unmute the mic and then please speak up and ask the question.
Good morning.
Yeah, good morning.
Yes. Can you hear me, Miss Filda?
Yes, I can hear you.
Yeah. My name is Anthony Harley. I'm from Ministry of Public Works and Housing Indonesia. I also alumni of SKKU. That's interesting research. I think it can be developed for the next research. I have several questions because the video was unclear. So first, I want to ask about where is your study location, and second, my question is, did you validate or calibrate your model with the field data? Thank you.
Thank you for your question, Mr. Hali, and nice to meet you. The first question is, where is the study location? For this paper, I using initial depth, so it is I didn't use for the field area, so it just initial depth. I mean the numerical modeling only use initial depth using equilibrium beach, and then I add the soling area using question Ito and Taminoto. And then about the real case, actually our research is very early study. So for in the real case, we need to more develop this model. Thank you. How Mr. Havli?
Okay, thank you for the explanation. I think your research is nice and it can be developed for the further project or research, and maybe from the presenter one, I think that's also sea level rise. It can be combined also. Thank you.
Okay, thank you for your suggestion and question.
Okay, so we will have one more question for Miss Filda. Is there any one more question?
Thank you.
Hello, Miss.
Pak. Okay. You can
Okay.
go. You can go, Pak Latif.
Oh, please, Pak Mr. Mr. Latif.
Lufti.
Oh, Mr. Lufti, yeah. Okay.
I'm sorry. Hello, Miss. Maybe you mentioned in your presentation that convex beach have the more vulnerable than concave profile beach, right? Did you test the concave beach so you can conclusion that?
Okay, thank you for your question. Actually, I haven't conduct the convex beach, concave beach phase. We did the we choose the convex beach because the submerged rock effect, the formation of the convex beach due to the reflection, so that it will catch sediment on the behind of the beach. So if the sea level rise become rise, we think it will be more eroded than other beach. So yeah, I know that our study need more develop. So in the next we will try to other beach face, such as for flat beach face and then concave beach also.
Okay,
Yeah.
thank you.
Okay.
Okay, thank you very much for the question. It's a very interesting topic for research, and I believe you can, Miss Filda can also develop the research further. So thank you very much for the presentation. We will continue to the next presenter. The next presenter is Miss Jingying Yuan. Mr. Jingying Yuan.
Hello everyone, my name is Yuan Jingying, come from Zhejiang University, Ocean College. My report name is the geochemical characteristics of hot springs. Hello everyone, my name is Yuan Jingying, come from Zhejiang University, Ocean College. My report name is the geochemical characteristics of hot springs discharged in the volcanic area,
we will
southwest
play
of
your
China.
video, and then after that,
Here is
please
the content.
respond for the discussion session.
Firstly,
Okay.
I will briefly
Okay,
introduce.
we can play our. We
My
can play
name
the
is
video.
Yuan Jingying, come from Zhejiang University, Ocean College. My report name is the geochemical characteristics of hot springs discharged in Tengchong volcanic area, southwest of China. Here is the content. Firstly, I will briefly introduce what is hydrothermal circulation. From this figure, we can see the hydrothermal system can divide into three parts: recharge zone, reaction zone, and the discharge zone. The water percolates downwards through fractured crust. The water is heated and then undergoes chemical modification through reaction with the host rock in reaction zone. Finally, the hydrothermal fluid rises up to the surface along the discharge zone.
I think there's no voice.
Hydrothermal circulation plays a crucial role in cycling of material and energy between the lithosphere and the hydrosphere. This figure showed us the hydrothermal gas circulation, we can see the main source of the hydrothermal gas. Okay, let's talk about the study area. My study area. Hello everyone, my name is Yuan Jingying, come from Zhejiang University, Ocean College. My report name is the geochemical characteristics of hot springs discharged in Tanchong volcanic area, southwest of China. Here is the content. Firstly, I will briefly introduce what is hydrothermal circulation. From this figure, we can see the hydrothermal system can divide into three parts: recharge zone, reaction zone, and the discharge zone. The water percolates downwards through fractured crust. The water is heated and then undergoes chemical modification through reaction with the host rock in reaction zone. Finally, the hydrothermal fluid rises up to the surface along the discharge zone. Hydrothermal circulation plays a crucial role in cycling of material and energy between the lithosphere and the hydrosphere. This figure showed us the hydrothermal gas circulation. We can see the main source of the hydrothermal gas. Okay, let's talk about the study area. My study area is Tanchong, is the boundary of Eurasian plate and the Indian plate. The collision and the compression of the two plates have intensified the crustal activity and frequent magmatic activity. The hot springs and the different volcanic rocks are widely distributed in Tanchong along the faults. Okay, next part is the materials and the method. These photos showed us the sampling process. There is the samples information. We can see some springs we can't get the gas samples because this springs is too low and the temperature is so high. It is too difficult for us to collecting the bubbling gas. Here are listed the analysis method for different type of samples. We can see the isotope geochemistry is the main method we used. Okay, next part is discussion. We determine the source of helium by this figure. We can see the Huaitaijing, Huanghuaqing, Xiaotangba, and Dapingzi. These four springs showed higher mental helium contributions, but the Shiqiang, the Huadong, Datang, and the Heilitang showed the lower contribution of mental. This means these four springs are hardly affected by the mental. Okay, we also discuss the source of carbon dioxide. We can see only Shiqiang and the Xiaotangba were largely affected by the limestone and the sediment. Other springs mainly come from mental. We use a thermal diagram to explore the source of these three gases: oxygen, nitrogen, and argon. Because the oxygen will be consumed during the hydrothermal cycle, the oxygen in samples come from the sampling air pollution at time or after sampling. Other sample points are between air, saturated water, and air, indicating that nitrogen and argon may come from groundwater and mixed with air. Furthermore, we can analyze its source through the linear relationship between nitrogen and argon. As shown in the figure, there are three different groups. DT and SHD showed completely different linear relationship between nitrogen and argon, which is roughly parallel to the air saturated water, Okay, let's discuss about fluid samples. This figure showed us the hydrogen and the oxygen isotopic composition of samples. We can see that most of samples plots along the common regression line. Some scientists thought it may be resulted from the mixing of two end member or an evaporation process. But considering the hydrogen and the oxygen isotope composition is very low, so we preclude any mixture with volcanic water, which suggests that the evaporation is the main process controlling the hydrogen and oxygen isotope composition in Panchong. Now we also see that ZZQ and HGQ they have the obviously oxygen shift, which indicates that the water-rock interaction of these two springs is relatively violent. We use this turtle diagram to determine whether the water have reached equilibrium. We found that most samples belong to partially equilibrium waters or emitter waters. So we use this geothermometer to calculate the temperature of reservoir. Here is the calculation result. We can see the HGQ and the ZZQ showed the highest temperature. And we know the temperature is one of the factors influence the water-rock interaction. This result is consistent with the result of hydrogen and oxygen isotope. Previous research tested the magnesium isotope of volcanic rocks in Panchong, and the magnesium isotope composition of rock is very low. So they believed it's the result of the mixing of deeper magnesium-rich carbonate melt. And whether this deep melt would affect the shallow hot springs, which aroused our curiosity. So we tested the magnesium isotope composition of the hot springs. From these figures, we can see there is no correlation between magnesium and chlorine, indicated the magma activities didn't contribute to magnesium, except for the river and the Shiqiang spring. All the samples showed a negative correlation, indicate that these hot springs may have the same source or experience a similar geological process controlling the magnesium isotopic composition. So now I will talk about the main magnesium source in the Earth. The mantle covers more than 99% of magnesium on the Earth. The delta 26 magnesium is minus 0.25. And the seawater, the average of seawater is minus 0.8 and 3. And previous studies have shown that the value of magnesium doesn't change with change in position, depth, temperature, and salinity. Here is the river and the crust magnesium. Now I will talk about the magnesium isotope fractionation. In the subduction zone, the source of its materials is very complicated, but due to the chemical property of magnesium, it tends to stay in the rock during the slag dehydration process, and the resulting magnesium isotopic fractionation is very limited. The relatively homogeneous magnesium isotopic composition of the mantle also indicates that potential melting and the magma fractionation will not cause magnesium isotopic fractionation. However, in the low-temperature geological process, previous studies have shown that lead magnesium is preferentially used in the carbonate precipitation process, which will cause significant isotope fractionation. According to the above formula, we judged whether there is carbonate precipitation by log K. The results show that 赖姓、石墙、太和, etc. springs, they all have carbonate precipitation. The original magnesium isotope composition were changed. So there is some summary of my studies. We divide the gas samples into 3 groups and found that the contribution of detrimental material is related to the spring's location, we can see. And the source of magnesium in Penchong hot springs is not related to magma activity. And except for rock leaching and river inputs, Shiqiang hot springs may have additional source of magnesium. The precipitation of carbonate have greatly changed the magnesium isotopic composition of the hot springs. And here is the references. And thank you.
Okay, Ms. Yuan Jingying for the presentation. It's very interesting topics. So yeah. Maybe if anyone have a question regarding the topic, you can ask directly.
Yes.
Okay, Mr. Fajar.
Thank you. Miss Jingying Yuan.
Yes, I can hear.
I can hear your good voice also. 你好.
你好.
Yeah, it's very interesting, very comprehensive, very I think very genius geochemical work. I appreciate that really, especially the magnesium, Miss Jingying. Your conclusion mentioned that the magnesium on the Tangcheng hot spring.
Yes.
You assume that it's not coming from the magmatic. Then where it comes from? And yeah.
I think it may come from the leaching from rocks, or the mixing with the river, because the river shows a high content of magnesium.
I see, from rocks. So that is a possibility for the geological environment, deposition environment of Tangcheng hot spring is also the ancient sea. So it has abundance of magnesium on its rock. How do you think?
Pardon, I can't understand your question.
I'm sorry. The Tangcheng hot spring.
Yeah.
Do you have any preference for its geological lithology? I think it is possibility. It has possibility that its lithology of the round of Tangcheng hot spring is deep water, so it has abundance of magnesium.
Because the Penchong is the boundary of 2 plates, so it's and the Indian plate, with the increase of pressure and temperature, the Indian plate will potentially melting, and the deep
thus the deeper materials will influence the shallow water by the magma activities. So we also want to understand the magnesium cycle in the subduction zone, because the previous studies, most scientists focused on the rock, so they do little works on the hot springs. So it's our so we pay a lot of attention to the hot springs.
Okay.
Okay. Thank you.
Thank you. It's clear.
Thank you for your question.
谢谢。
谢谢。
Okay, thank you. Yeah, but unfortunately, the time limit is finished. So thank you very much for Miss Yuan Dinging for the discussion session. Thank you. And so
thank you.
Yeah. So we will move on into the next presenter. Next presenter is Miss Dwi Amanda Utami.
Yeah, hello.
Hello. Yeah. Okay. We will play your presentation video first. Okay, we can play.
Hi everyone. My name is Dwi Amanda Utami, and together with my colleagues Iwan Pramesti.
Hi.
Hi everyone.
Hi.
Hi everyone. My name is Dwi Amanda Utami, and together with my colleagues Iwan Pramesti Anwar and Karina Aprilia Sujatmiko, we would like to present our research, influence of variability to coastline dynamic in the small uninhabited reef islands of Kepulauan Seribu. Background of the study: Indonesian archipelago comprises more than 17,000 islands. The reef islands throughout the Indonesian archipelago are usually low-lying, and this is considered among the most geomorphically sensitive landforms to changes in sea level, wave process, sediment supply, and anthropogenic impacts. Among the best known coral reef island in Indonesia is Kepulauan Seribu, and by 2019, the reef islands are host to more than 24,000 people. Kepulauan Seribu is facing threats from urban pressure and pollutant, as well as erosion due to natural events such as wind and wind-generated waves. The reef island formations and development. Coral reef islands are accumulations of unconsolidated carbonate sand and gravel that deposit on reef platforms by wave and current process. The island formations and development is partially controlled by the production and supply of detritus and ecological process within the reef system. The morphological development of platforms is modulated by variation in sea level at millennial timescales. However, at shorter time scale, island formations and development is largely determined by hydrodynamic process. The study area in this research is small uninhabited reef island in Kepulauan Seribu, namely Semak Daun Island and Opak Kecil Island. Kepulauan Seribu located in Java Sea. Java Sea is characterized by monsoonal wind with a reversal between the west monsoon that occur from December to February and east monsoon that occur from April to October. The west monsoon is stronger, but the east monsoon lasts longer. Movement of beach sand driven by the alternating monsoonal wind-induced waves in Kepulauan Seribu occasionally result in negative sediment budget. The monsoon wind is known to interact with an interannual phenomenon such as El Niño South Oscillations and Indian Ocean Dipole. A positive IOD strengthens the wind speed in Java Sea during the east monsoon, and hence contributes to increasing the significant wave in Java Sea. A negative IOD weakens the wind speed in Java Sea during the west monsoon and hence contributes to decreasing the significant wave in Java Sea. The specific objective of this study is to examine the reef shoreline response to seasonal climate variations using satellite data that encompass yearly monsoon cycle and positive or negative IOD event. Basic understanding of many physical processes, including erosion on small islands, can be initiated by observing the displacement or changes of positions of any related features with respect to its spatial setting. And ultimately, Kepulauan Seribu provides a natural laboratory to evaluate the effect of changing climate on coral island shoreline. A good understanding of seasonally controlled changes in which system of reef sediment is important for adequate coastal management decision. The characteristic of monsoon wind in Kepulauan Seribu, here is the climatology of monthly average wind from 2009 to 2018 in Kepulauan Seribu water. The data is obtained from ICZM WWF. Here we can see that the direction of wind magnitude in Java Sea show bimodal distributions that the difference is almost 180 degree and it's ranging from 90 to 150 for west monsoon and 310 to 325 degree for east monsoon. And it is thought that the persistent mechanism from east monsoon wind dominate the process of sediment transport and considered to overwhelm higher wind magnitude during west monsoon. Here is the Indian Ocean Dipole Climate Variability Index data using Dipole Index from the year 2009 to 2018 provided by the State of the Ocean. And here is the average of monthly wind speed from 2009 to 2018 in Kepulauan Seribu water and its surrounding. In 2009, the monsoon wind coincides with neutral IOD phase. And here we can see that the west monsoon has stronger wind speed compared to the east monsoon. Weaker west monsoon wind was observed in 2010, which coincides with stronger negative IOD event. And as we can see here that the west monsoon is weaker than the year before that coincides with a strong negative IOD event. Meanwhile, the Indian Ocean witnessed a weak positive IOD event in 2015. And here is for the monsoon wind for west and east monsoon. The shoreline dynamic based on the satellite image observation of small inhabited island in Kepulauan Seribu. First is the Smackdown Island. In December 2009, this is when the west monsoon that coincides with neutral IOD phase. Here we can see that the shoreline is tied in with the water vegetation boundary. In July 2011, here is the east monsoon that coincides with positive IOD event. We can see here that the tail of the island is shifted to northwestward. November 2014, here is the transition phase from east monsoon to west monsoon that coincides with negative IOD event. Here we can see that the shoreline seems to move southward, and the area it seems that decrease. September 2015, here is the east monsoon phase that coincides with positive IOD. We can see that the shoreline is shifting northwestward, and the area seems to accreted. Another example from small uninhabited island in Kepulauan Seribu. This is the Opak Kecil Island. In December 2009, when the west monsoon coincides with neutral IOD event, The shoreline seems to tied in with water vegetation boundary. In September 2008, when the east monsoon wind coincide with weak positive IOD event, the shoreline seems to located more to the northward compared to the year after. November 2014, when the transition from east monsoon to west monsoon that coincide with negative IOD, we can see here that also the shoreline seem to shifted more to the north, and the island also is decreased. In September 2015, when the east monsoon coincided with positive IOD event, we can see here that the tail of the island seems to increase, and the shoreline shifted northwestward. Furthermore, the shoreline length and area accretion or decretion can be observed based on different monsoon and IOD year. However, positive and negative IOD year seems to give more pronounced change to shoreline shift and area accretion and erosion. The same phenomena here we can observe in Opakacil Island, that the negative or positive IOD year seems to give more pronounced change for the shoreline shift or area accretion or erosion. Perspective for coastal protection in uninhabited island. In uninhabited island, erosion and accretion are a great concern since it affects the livelihoods of coastal communities. Meanwhile, in uninhabited island where there is no permanent resident, this phenomena is mostly overlooked. Several uninhabited islands in Kepulauan Seribu are used for conservation, mostly for housefly turtle protection and coral reef ecosystem. Several other islands are popular tourist destination, suitable for snorkeling and diving activities. In the small uninhabited island, coastal protection by nature approach is more suitable. And for conclusion, shoreline shifting due to opposing monsoon in uninhabited platform of Kepulauan Seribu can be acknowledged from satellite image visual interpretation. In this study area, shoreline position is shifted southeastward during west monsoon and northwestward during east monsoon. Shoreline shift due to opposing monsoon were observed throughout all the years. However, positive or negative IOD event seems to give more effect on the shoreline movement compared to neutral IOD years. And in order to maintain its sustainability, utilization and management of uninhabited island might best be done with conservation types approach. Thank you very much for your attention, and if do not hesitate to ask if you have any question. Thank you.
Okay, thank you very much for the presentation. Now we will come into the discussion session. So please, anyone if you have any question, please just unmute your mic. Thank you. Hello, please. Hello, Miss. Hello.
Yeah, hello.
Mr. Lutfi, yeah, please.
Yeah, maybe I asking a little question. Yeah, I get from your presentation the shoreline, the coastline you get from the satellite, maybe Google satellite. is there any effect of the different satellite digitation, temporal satellite digitation, to the different coastline? Maybe you digitized in 2009 and you digitized in 2020. Maybe did have a different accuracy of the satellite that can affect of the coastline, or no?
Yeah.
This is at the same level.
Yeah, okay. Thank you for your question, Mr. Lufti. So, of course, there's a difference accuracy, I think, for the satellite, because what I use is free from Google Earth. And I think the accuracy is quite big for such as small place like Kepulauan Seribu and small islands like my study area. So if we want to know more accurate about the shoreline shiftings, accretions or erosions on the small island, I think it is better if we have take a look at another satellite image, or we compare, yeah, maybe the one that we should pay or not free in the internet, maybe it will give more detailed result.
Yeah, I think because maybe we have the satellite resolution, high resolution satellite, maybe a VP or BIG, you can support your better result.
Yeah. That's really true. But what I want to show here is first that there is a result from Rahmayani. Her study shown that the IOD giving the impact for west and east monsoon on the Java Sea, and then there's also preliminary study from Purbandono that he see the shoreline shift from the satellite. So I want to combine both study, and I want to see the IOD and east and west monsoon on a small island using the free satellites on the internet. Yeah, maybe for future research we should consider using a better satellite image.
Yes. Okay. Thank you, Miss.
Yeah. Thank you.
Okay. Thank you, Mr. Lufti. So maybe one more question.
Yes. One more question, please.
Okay. Please, Mr.
Yes. From Tubagus Solihuddin from KKP. Yes. Thank you, Amanda, for your presentation. It's very interesting. So your research examine the influence of the monsoonal drift and IOD impact to the sediment shifting in the small island, right? So it's very interesting. It's very clear. I noticed from your presentation the geomorphology of the coral reef of the island. The orientation is likely northwest to southwest and northeast to southwest. So from the orientation, it's very clear the impact or the influence of the monsoonal drift. My question is which monsoonal drift more influence to the sediment shifting and to form the geomorphology of the island?
Yeah. Thank you, Mas Tubagus. So maybe I already explained in my presentations, but I know maybe it's not really clear. So is it possible if I share screen? No?
You can just answer.
I can share the screen. Okay. Yeah. So this is the study from Purbandono. If you can see here, Mas Tubagus, yeah. Can you see my screen?
Yes, please.
Yeah. So this is the west monsoon in the Java Sea, and as we can see here, that the west monsoon have stronger wind speed. It occur from December, January, February, and sometimes in March. And also this is the east monsoon. It has lower wind speed compared to the west monsoon. However, it lasts longer from May until October. So according to Purbandono, his research conclude that the east monsoon, although the wind speed is lower compared to the west monsoon. However, it lasts longer. So the east monsoon is the most important driving mechanism for the shoreline shifting in the Java Sea or in Kepulauan Seribu.
Okay. Yes. Thank you. Very clear. So because it's related to the geomorphology, the geomorphology of the north coast of Java. If we notice the direction or the orientation of the delta is much more to the west. So it shows that the monsoonal drift from the east or the east monsoon more influence to form or to form the delta orientation. So yes, thank you for your explanation.
Yeah, thank you.
Okay, thank you, Mr. Tubagus, for the question. Yeah, very interesting topics. So, but unfortunately, the time limit is finished. So we need to move on to the next present. But thank you very much from Miss Dwi Amanda for the presentation and the discussion. So the next presenter is Miss Ria Rista Rahmawati.
Good morning, ladies and gentlemen. Today I would like to present my presentation of the analysis based on long-term data observation of. Good morning, ladies and gentlemen. Today I would like to present my presentation of the analysis. Good morning, ladies and gentlemen. Today I would like to present my presentation of the analysis based on long-term data observation of MSAT beach program in Beach for coastal assessment. Okay, my presentation will start with the introduction and then continue with the objective and then study area and data and also method and the data and discussion and I will close with the conclusion. Okay, let's start with the first chapter of the introduction. As we know that Indonesia beaches are dominated by the beaches in the central to the eastern part of Indonesia. And so many beaches in the world face with the erosion such as Kuta Beach. In case of Makau and Soseda Beach, if the tidal is less than meter, the tidal effect will be minimal, but its influence will be increased with the tidal rate, so that it will decrease the mobility of the coastline following the tidal level. And so many ways to overcome the erosion, for example.
Yeah. I saw Miss Ria Rista request to present online because
because of the video is not clear.
Yeah, I think the presentation, the video is not very clear, and also the noise. There's a lot of noise, I think, in the voice. So maybe you can present in the online, but you only have 12 minutes for the presentation, so you can start now.
And how to connect with the, because I cannot see the connecting.
You can share screen your presentation.
Share screen. Okay, can you see my presentation?
Yes.
Okay, I will start my presentation.
I think you should switch to the presenter mode.
Okay, I will present like this.
Yeah.
Okay. Good afternoon, ladies and gentlemen. Sorry for not clear the video, and I will present online. So today my presentation is about the littoral drift analysis based on the long-term data observation of mesotidal beach profile in Kuta Beach, Bali for coastal retreat assessment. So my presentation today will the first about the introduction, and then I will continue with the objective, and also study area and data, and also method, result and discussion, and I will close with the conclusion. So this is, as we know that Indonesia beaches are more dominated by the meso and macro-tidal beaches, especially in the central part of Indonesia to the eastern part of Indonesia, and most of the beaches in the world face with the erosion, such as in the Kuta Beach. And in the case of meso and macro-tidal beach, if the tidal range is less than 2 meters, the tidal effect will be minimal, but its influence will be increased with the tidal height, so that it will be increase the mobility of the coastline following the tidal level. And then, as we know that to overcome to the erosion, there are so many ways. For example, with the breakwater and then with artificial reef, but it's still the matter of the debate because of the littoral drift effect and the littoral transport effect, the direction of the wave, which can reduce the level of protection against the beach. And here, by considering the tide and the littoral drift as the main factor for sediment transport, then the temporal beach with trend change induced by the littoral drift can be observed for shoreline retreat analysis. Then, from my introduction and background, so the objective of my research is to analyze the temporal variability change in the beach profile as response to the tidal height fluctuation, and also the analysis the temporal variability of shoreline change, and finally to analyze the littoral drift based on the long-term data observation. Okay, and then we move to the first page of the study area. So here I use the data 7 years observation of beach profile monitoring from the Ministry of Public Work and Housing from 2008 to 2015, and then the data then reprojected to UTM 50 South with the geodetic datum WGS84, and we have 13 cross-shore surveys, and I use the Bonoa port tide as reference with the MSL 1.3 meter and HWL 2.6 meters. And if we look close up to the area, that the area consists of 13 cross-shore surveys that I divided into 3 parts: the north part, the center part, and then the south part. And if we look at the place, there are two submerged breakwater, and there are 2 detached breakwater around the coast area. And then the method that I use for this research is I combine the long-term data observation of beach profile and tide data, and then I analyze the temporal variability change of beach profile, and from that we got the fluctuating profile analysis in HWL and SL, and then we can calculate the sand volume gain loss. After that, we analyze the temporal variability change of the shoreline in HWL and MSL, and we can got the shoreline rate change every year. And with the MEPASOL, we can detect the shoreline equilibrium position, and we can get the predominant wave and shoreline orientation. And then after all, we can analyze the littoral drift analysis pattern and magnitude, and finally we can assess the coastal retreat. And then we're gonna discuss about the result from my research. As we can see in the picture, that it was found that the southern area had the same scheme progress, retreat, and return to the same position and repeat as well. As we can see in the picture, that in the southern side and the northern side, it has same stable profile, except in the LK12 in the northern, it's progress and deposition a lot, because there are submerged breakwater, detached breakwater in front of the LK12. And then if we compare with the center area, only seasonal variation in accretion and explosion occur. As we can see in the picture, that the pattern is deposition, and erosion in the LK8. And then it shows that the area with low potential eroded easily. However, in area with high potential will erode easily, and in low wave potential will be deposition easily. I'm sorry, this is it means that in low wave potential it should be deposition easily. And then we can see in the volume change and sand loss volume by year, it shows that the profile experience accretion in 2008 until 2014 and experienced eroded again in 2015. And for that, we know that the profile retreat from initial year observation which have inflection point between MSL and HWL. And then finally, based on the beach profile, we calculate the beach width in HWL and MSL, and then we can calculate the main position and shoreline rate in every LK. And we can get the information that the annual change in the shoreline reference in HWL has maximum erosion rate above 2.34 meter per year. And then in the MSL, the maximum erosion rate is about 1.37 meter per year, with the deposition rate is 0.38 meter per year. And if we analyze this from the slope, we can know that the slope show that beach relatively stable, except in the LK6. As we know here, the LK6 have 13.69. It's because maybe in the LK6 in front of LK6 there are two submerged big water that lead the deposition around that place. And the result of HWL of MSL show that the profile will enough. Then here I use the DePasol as the MATLAB GUI developed by the Beach and Shoreline Management Center, Sukiwang University, to find out the shoreline equilibrium position. As we can see that the shoreline position equilibrium is the purple and yellow line here. And it found that the predominant wave angle around 80.2 meter, that it will be used to analyze the shoreline orientation.
Miss Ria, 5 more minutes.
Okay. And then for the shoreline analysis, when we analyze the shoreline equilibrium and we overlay with the shoreline position from the beach profile, it shows exactly that the in HWL position is more better and satisfying than in the MSL. And finally, and if we analyze the littoral drift analysis, if we judge that the rotation in the counterclockwise, the duration was made in 2011, 2008, it showed the same direction from the south to the north. And then, however, considering the retreat with of HWL and MSL is small in the place, it's just that the shoreline retreat in 2015 had high wave effect at the level effective of HWL. And then finally, if we analyze the littoral cell direction and magnitude, it shows that it has different movement from 2008 and 2011 and 2011 and 2050, where in the 2000 from south and north, and the other one is not from south. But if the sand volume of the sedimentary system is well maintained, but as the main wave direction changes counterclockwise, the beach erosion will continue on the southern coast and deposition in the northern part. And thus the general erosion likely to occur without the controlling such littoral pattern. And finally, I want to conclude my research. And the first one is the beach profile analysis result in the East Baseline monitoring show that the beach profile in HWL and MS are relatively stable, with profile and also well maintained sand volume. And the annual change in the shoreline reference in HWL and has maximum erosion 2.34 meter per year, and in the MSL is around 1.37 meter per year. And as the main wave direction changes counterclockwise, the beach erosion will continue on the southern coast and the deposition in the northern part. Thus, the general erosion is likely to occur without controlling such littoral pattern. And also, nourishment and the completion data information is recommended to get the better result. And finally, hopefully, this study can be used as input or applied in the assessment of coastal erosion as one of the strategic steps in the determining mitigation measure. Okay, thank you very much. That's all from my presentation. If any question,
yeah. Okay, thank you very much, Ms. Ria Rizka, for the presentation. So just for to shorten the time. Please, if you have any question, you can unmute your mic and just ask the question.
May I?
Please, Mr. Todd.
Yeah, thank you very much, Pak Moderator. Yeah, okay. My name is Toto Supriyo. I come from Oceanography Department of ITB. So I have two questions for you. The first question is, what is the definition of equilibrium speeds in your study? And my second question is about how did you validate your results about the littoral drift as you get from the analysis of the shoreline? You get probably 2 point something per year. So how did you validate these results? Thank you very much.
Okay, thank you very much, Mr. Toto. So for the second questions, actually to validate the littoral pattern, direction, and magnitude, I compare with the direction of the wind. So in case of Bali Beach, it's influenced by two kind of monsoon. The first one is the west monsoon, and the second one is the east monsoon. So based on the direction, it shows that the pattern of the littoral drift is from south to the north. It's dominant in that area, and also originally the place, the submerged big water and detached big water in that area, it's built by government because of the littoral effect of the Ngurah Rai Airport littoral effect. So in the conclusion that the result of my study with the wind direction in that area is have same direction, dominant same direction. And then can you repeat your first question?
The first question is just about your definitions about equilibrium, because there are many definitions about equilibrium feeds. Yeah.
So,
for example, in point of view of sediment balance or something like that. So what is your definitions about equilibrium?
Okay, thank you, Mr. Toto. So the equilibrium of the MAPASO tools that I use in this research is based on the Professor Xu and Evan about the curve by shoreline. So by using the software, I define the shoreline equilibrium by define the initial downdraft in the tip of breakwater and the final downdraft in the peak, the shoreline. So it based on the formula of the curve by, so it will be generate the curve shoreline based on the structure of breakwater and the tip of the shoreline.
Sorry to cut. Actually, I know the criteria of Professor Xu. This is very long time ago. It's about 70s. It's related to the wave conditions actually, and also headlands. The curve fits. So there are several equations also about the Professor Xu proposed several equations actually, and it's depend on the wave condition actually. So I would like to know the backgrounds of the equilibrium definitions that you use in this study actually, because I'm sorry, probably I missed with your explanation about the wave conditions. So that's why I asked about the equilibriums that you mentioned in your study. You just study about the tidal effects or tidal, what is influence on the pitch profile and also littoral drift. But I'm sorry, I cannot get the explanations about the equilibriums definitions that you use. I know about the Professor Xu definitions about equilibrium. It's about the headlands.
Yeah.
If we have headlands, then we will stabilize the beach. Hey, I'm sorry, Pak Moderator. I'm sorry.
Okay.
Do I have a little time to give a comment?
Yeah, actually, the time
if
is...
already, that's okay. Thank you.
Okay. Yeah, sorry for...
Thank you for the answer.
Maybe,
Thank you, Pak Moderator.
Maybe Mr. Toto, for the equilibrium, I use the parabolic type equilibrium, and for the shoreline, actually why I overlay with shoreline equilibrium, because of the equilibrium is show that no deposition and erosion again at that area. So I want to investigate only from the equilibrium position how far the erosion and deposition happen for the beach profile monitoring. So that's all I use the equilibrium shoreline.
Yeah,
Okay,
probably we need to discuss in detail
yeah,
later on.
Yeah,
Okay,
okay.
Thank you.
Yeah, sorry for cutting the time, because we have a very tight time. So we also have one more presenter. So I'm sorry to cut for the discussion. Yeah. Yeah, for the another question, sorry, I cannot provide for the another question because the time limit is already finished. So thank you very much from Ms. Ria Rista and Mr. Totok for the discussion. It's very interesting discussion. So maybe if you have any more discussion, you can directly contact each others. So thank you. And so now we move into the last presenter from Sun Langsin.
Hello everyone, I'm Sun Lanxin from Zhejiang University, Ocean College. The topic of my report today is provenance of sediments in the Gulf of Guinea, evidence from geochemistry. I will give a speech from the following aspects. The position of the red dot in the figure is the sampling position of this experiment. In this picture, we can see the information of sample stations in Niger Delta area of Gulf of Guinea. In this experiment, we mainly use 3 experimental methods to measure total carbon, total organic carbon, major and trace elements. Then came to the third part of the experimental results. We can see that GC9 and GC10 have the same change trend, and the overall change range of GC5 is small. In the upper 50 centimeter sediment, the total carbon content of GC5 decreased the fastest with depth, followed by GC9, and the total carbon content of GC10 showed an increasing trend. Under 50 centimeter, the total carbon content of GC5 almost remained unchanged. Only there was a small increase at the depth of 106 centimeter, and the decrease rate of GC9 was the fastest, followed by GC10. The 3 sample columns show the obvious Delta European negative anomaly. Based on the analysis of the experimental data, we believe that the sediments in Niger Delta of the Gulf of Guinea mainly come from the following 4 sources. Terrigenous input, accounting for about 37 to 69% of the total sediments, is mainly transported by rivers. In marine sediments, with the degradation of microorganisms, organic-rich sediments gradually accumulate on the seafloor, As time goes on, later diagenesis occurred in organic compounds, accompanied by hydrothermal fluid alteration. These are some of the previous literature. Thank you for watching.
Yeah, okay, that was a presentation video from Miss Sun Langsin. But unfortunately, Miss Sun Langsin is not here, so we cannot have any discussion session. Yeah, okay. With the end of the presentation from the Miss Sun Langsin, so this is also the end of our mini symposia session in the room B. Thank you very much for all the participants that attend in this mini symposia. So maybe if you interested in to join in another symposia, you can come into room A or C, D, and E to hear what the topic with the another topic mini symposia. But you can also return to the main room to have announcement from the MC about our agenda in the next evening, afternoon, and tomorrow. Okay. Yeah. Okay, thank you very much, and see you later.
Thank you, Pak Hanif.
Yeah, welcome, Pak. Thank you.
Yeah.
seorang peneliti, menjadi seorang surveyor di lapangan, atau bahkan menjadi seorang perusahaan-perusahaan. Dan di sini untuk peneliti sendiri biasanya untuk mahasiswa yang ingin melanjutkan studi di berbagai universitas dalam atau di luar negeri, seperti Tokyo Institute of Technology, di Hamburg University, atau bahkan juga sampai Massachusetts Institute of Technology. Dan untuk field surveyor itu bagi orang-orang yang suka kerja di lapangan, tapi khususnya di laut. Contohnya di perusahaan seperti Strategy, di perusahaan Grow, atau perusahaan seperti Pagil. Dan yang ketiga adalah sebagai seorang analis lingkungan. Biasanya dibutuhkan untuk memberikan informasi kepada perusahaan-perusahaan yang melakukan industri gas atau pertambangan. Di sini seperti Freeport, Newmont, atau juga bahkan perusahaan seperti Pertamina, Total, atau bahkan
Established in 1920 with the name Teknische Hogeschool Bandung, Institute Technology Bandung is the oldest technical university in Indonesia.
Since 2008. Mr. Park got his PhD from Korea University in 2004 and worked for St. Louis University in US as visiting scholar. And he had adapted himself to seafloor hydrothermal mineralization system as well as manganese nodules and manganese crust. So the presentation for invited speaker will be 15 minutes, and then we will continue to the discussion session for 5 minutes. So to Mr. Sang Joon Park, time is yours.
Excuse me.
Yes.
I'm sorry, I don't have any my presentation screen, so just let me get some seconds to fix my screens. Sorry.
Yes, please take your time.
Can you see my presentation?
Yes, but you need to slide show.
Sure. Okay, let me try it. How about you?
It's still two slideshow. I mean, the main one and the next slide.
Oh, really?
Maybe you could choose the.
Sorry.
It's okay.
Still?
Yes, still two mode.
박사님, 그 슬라이드 쇼 하시기 전에 그 슬라이드 쇼 메뉴에 오른쪽에 보시면 발표자 도구 사용이라고 체크가 돼 있을 거예요. 그걸 끄시면 그냥 프레젠테이션 화면이 나옵니다. 지금 발표자용 화면이 자꾸 쉐어링 되고 있거든요.
어디 부분이죠?
그 파워포인트의 슬라이드 쇼 메뉴의 오른쪽 편 끝에 발표자 도구 사용이 체크가 돼 있으실 거예요.
발표자 그걸
그걸 끄시면 돼요. 예.
How about you?
You need to slide show.
이제 슬라이드 쇼 시작하시면 됩니다. 슬라이드 쇼 처음부터. 예. 예.
됐습니까?
지금 혹시 화면이 두 개인가요?
예, 두 개인데.
그러면 발표자용 도구 사용 체크하시고 위에 자동에서 클릭이 안 되시죠, 오른쪽에.
네.
그러면은 그거 끄시고.
그러면.
화면.
PDF로 차라리 가는 게 낫지 않을까요?
네네네.
네. 오케이. 이거 처음 사용해봐갖고. I'm sorry, this is first time to share my screen. So I will go with my PDF files instead of the.
PDF filenya.
Can you see my PDF file screen?
Yes, we can see now.
Now.
Maybe you can click full screen mode. Yes.
Oh, still on there?
It's okay now. You
That's
can.
okay now?
Yes, please.
Yep. I'm sorry.
Bapak Ibu yang masih di sini,
sorry.
Mohon dikabari saya, kita bisa
Still have a problem in my.
ingin masuk ke room mana.
Oh. Can you see my presentation?
네, 잘
Yes.
보입니다.
Yes.
Yeah. Good afternoon. Just please excuse me, because I'm a novice for using these programs. So anyway, thank you for your having me to get a chance to present my talk. My name is Sang-Jun Park from Korea Institute of Ocean Science and Technology. That is a kiosk. I'm here to this afternoon to talk to you about deep sea bed resource explorations and developments shortly in terms of the activity of Korea, as well as recent achievements in the field of seafloor hydrothermal deposit explorations. My talk is not try to and illustrate to you to have details of the nature of seabed resource, but I'd like to see try to present outline of the deep sea bed resources exploration by Korea and give a simple insight of deep sea bed resources. Still, I'm sorry. 박사님 괜찮으십니까? 지금 보이는 게?
페이지 다운이 안 되신 것 같은데요?
됐습니까?
아니요, 화면 변화가 없네요. 됐습니다.
됐습니까?
지금 슬라이드가 풀스크린은 아니지만 지금 상태로 하시는 게 네.
지금은 어떻게 됐습니까? 지금 풀스크린 안 됩니까?
풀스크린은 맞는데요. 스크롤링이 되고 있거든요.
예.
네.
지금 화면에 딱 맞게 보입니까?
네네네. 이렇게 진행하시죠.
예. 어쩔 수가 없을 것 같은데. I'm sorry, So yeah, today's talks on what is a deep sea bed memoirs, and secondly, I'm going to go to the exploration, see a detail of explorations in Korea, and lastly, I would like to say about why deep sea minerals is important. So first of all, I would like to see you to what type of deep sea bed mineral resources we have. As you know, conventionally, there are three different types of seabed resources. The polymetallic nodules, so-called manganese nodules, a covered crust, so-called manganese crust or ferromanganese crust, and SMS deposit, that is stand for seafloor massive sulfide. We often call seafloor hydrothermal deposits. Polymetallic nodule, as you know, situated in deep sea, about 4,500 or 5,000 meters depths in the sea plane, which has mangan, iron, nickel, cobalt, and copper. Cobalt rich crust, situated at the top of the sea mount, which has 800 to 2,000 meters depth, which has cobalt, nickel, copper, and mangan elements. Lastly, seafloor massive sulfide was called hydrosomal deposit in the seabed. So generally located in the deep sea from 300 meters to 3,700 meters depth or 4,000 meters depth. This deposit has copper, zinc, gold, and silver. So in this section, I will shortly present the state of the explorations of seabed resources by Korea and focus more on seafloor hydrosomal deposit as an example that we have found. I'm not going to go in details on hydrosomal deposit because of time pressures, but I believe these short descriptions will help you have insight how explore the deposit. Korea set out the deep similar research programs for preparation nozzle exploration in 1982, and eventually we carried out independent nozzle exploration in Northeast Pacific in 1987. Since 1982, KIOS have a span of the various deep sea seabed resources exploration program from manganese crust to hydrosomal deposit in deep sea. I'd like to emphasize on this deep sea bed exploration program in Korea have been the main driving forces for deep sea marine scientific researches, because the span of various and very important less of kind of programs. This simplified map shows exploration areas by Korea. Korea has 5 exploration tenements in 5 different locations from Northeast Pacific to the Indian Oceans. Nozzle exploration right from the ISA, that is International Seabed Authorities, that we have had since 1992. For example, these manganese nozzle tenements shows the 75,000 square kilometers. That is a very huge areas. So hydrosomal deposit or the manganese crust are also the comparatively smaller than nozzle tenements. Now we are going to examples of deep sea hydrosomal deposits. The reason that I picked up the hydrosomal deposit out of the other resources is the exploration for this deposit. Hydrosomal deposit is recently carried out, and we have more result to CU than the other seabed resources. This is a simplified maps exploration areas for hydrosomal deposits by Korea. These areas displays various tectonic environments of hydrosomal systems, so such like from arc to the mid-ocean ridges in the deep oceans through the back-arc basins, such like North Face basins. Hereafter, I'm briefly gonna introduce explorations results of the Tonga, Fiji, and Indian Oceans, especially in the Central Indian ridges. Here is first Tonga area. It's located nearby the arc systems. The diagram shows that the record how we have narrowed down the areas to target potential areas on the large areas. 2008 we have large areas, but the 2011 we already narrowed down the potential areas to find the hydrothermal project. The various tools have been applied to narrow down, and finally we found over 110 mounds and dams which are able to be metal ore bodies. You can see the lots of chimneys and mounds here. The photo shows the sulfide, which bearing the metals such like copper, zinc, and the lead. The right panels, the right panels, which shows some map showing the displaying the high resolution mapping results with the chimneys and the mounds locations. Here stands for red stars. You can see the red stars on the right upper panels. So that is, I just write it down of band sites or mound sites. That means, the large, number of chimneys and mounds, clusters on the some small areas. And we finally, we conclude these areas, has affected by some different hydrothermal systems within the same corridor. This kind of the different style of contracting style of the two field vents. It came from the different hydrothermal systems. Let's move to the North Face Basin. This research, this research, from now on, we move to the North Face Basin in the Motor Back Basin structures. And this is behind, the back of the arc systems. These basins has almost, not merchants, almost merchants lifting zones, such like the middle and ridges. As I mentioned before, the area is featured by abyssal hills, which is popular in middle and ridge, because this area is located in the Bagak basins, which is has almost merchants lifting zone. So you can see there are some abyssal hill along the north and south directions. So you can see the red arrows. So here is visualized map. This is a visualized map by ROB. They carried out the high resolution scanning on the top of the seabed seafloor, and illustrated well-defined chimney structures or mound structures. You can see that some. Can you see recognize the pinnacles along the abyssal hill? Very small, like a pin or pinnacles in there. This cluster of the pinnacles presents seafloor hydrothermal ore bodies. They are almost dead, and we can find some debris of the seashell, sometimes, some seashell or some sea creatures. We can meet, sometimes we can meet, foggy areas might be due to the, carbon dioxide emissions in the areas. Anyway, so many, lots of, chimneys and mounds, clusters in here. So other areas, here is, the examples that shows the well structures of individual mounds and the bands. So, and it shows how they cross, getting together some small areas. So like you see there's some pinnacles, there is a chimney, and they get together and make some big mounds. And we are expected is some very big ore bodies under the mounds. So that's what, that is our target for the explorations and developments. This is another areas. This is photos for one of the highest chimneys in the areas, which is 27 meters high. This is as high as 10 stories buildings or 15 stories building, as you can see in these pictures. It's very high. So anyway,
Mr. Park, your time, 3-minute lapse.
Okay, so so many find so many chimneys here. Okay, let's move to the Indian, which Central Indian ridges. We surveyed these big areas, 300 kilometers by 900 kilometers rectangle. The area, and we finally find the Chum Band Build. This is a very newly found in the Central Indian ridges. This is very important to us or the other researchers, because it is located in the ocean core complex. Is very ocean core complex is very important structures in the oceans. Anyway, we found the newly Chum Band Field in the areas, and the other one is the Omni Band Field. Okay, let's move to the final sections. Why are deep sea bed minerals? As you can see in the slide, we use lots of matters. It said very Americans born will need lots of metal for their livings. Approximately almost the 140 tons of materials or metals in the lifetimes. So in the cases, we need more the land-based mines, but this kind of the actions makes the very unpleasant situations. That's why we are looking for some other resources, and we need more the metals, and green also the green economy is need more the metals. So for example, when we make the one wind turbines, we need more just the more 500 kilograms of nickels and 1 ton of the coppers, we need more. So, and 12 times more copper created 1 kilowatt than the conventional power generations. And the other example is when we make the electrical beakers, at times we need more nickel and coppers and the rare earth elements. So that's why the lots of countries or lots of entity companies are interested in the sea floor, the deep sea bed resources. They are looking for the metals in the seabed. So I think like a Norwegian example, they had the oil and gas. That's kind of the big energy or the metal, or that's kind of things give the big rest to the Norwegian. So recently, the Cook Islands has looking for the way to exploitation of the manganese in order to have a sustainable growth by this kind of seabed resources. So I think, this kind of seabed resources is a very big chance to give wealth to the country, or give, chance, give raw materials to grow the electric cars and the green economy. Thank you so much, attention. Thanks so much.
Yes, thank you, Mr. Park. It's very interesting topic.
Yeah.
So we can find out that the Korean still has exploration program, and it always continue with a high resolution technique to find out what inside our seabed, right?
Yeah, right.
And your program has been investigated like Tongan and Fijian water, and also Indian Ocean, as you can as you shown before.
That's
okay.
Right.
So now I will open like interactively discussion between the participant and also the speaker. So I will let you to speak up or raise hand first, and then I will allow you to speak. Is there any question from the audience? You can raise hand, and then I will allow you to open your mic. While we are waiting the participant to ask, I have some question. Actually, since I'm also teaching like oceanographic geology oceanographic, so I'm interested about the technique that you use, that is the bottom survey. How accurate about the high resolution compared to other techniques in this program?
Actually, when we are looking for the searching for large area, at times we usually use the ship-based multi-beam. That is, just resolution will be maybe half kilometers or half kilometers. I cannot remember exactly, but anyway, when we use the ROV, remote to operate vehicles, there are times, the high resolution mapping or scanning, the resolution is, 50 centimeters by 50 centimeters, very high already. So that's why we can see, some chimney structures or some mound structures very easily. Yeah, 50 centimeters by 50 centimeters.
Okay. Yeah, thank you very much. Okay, is there any further question from the audience? You can raise your hand, or you can just chat in the chat box. Otherwise, I will move to my next question. Mr. Park, Pak Hansan, maybe you have a question regarding Mr. Park.
Thank you for presentation.
Don't push it anyone.
Yeah, actually, we also have cooperation with the CMMAI, Coordinating Ministry for Marine Affairs and Investment, and they also interested with seabed mining and development of about that. Yeah, so maybe if we can make a good program, maybe we can start something. Yeah, so I would like to ask your opinion. What is a starting point for cooperation for seabed mining? Yeah, between Korea and Indonesia. Yeah, thank you.
Did you ask me? Okay, I see.
Must answer, Mr. Park.
Yeah, in this field, it's not easy to find or explore some things under the sea. So I think there is I think two parts will be needed. That is, first one is the infra, such like the ships, and the other gears or equipments. The other one is the manpowers who are well trained to this kind of exploration. So I think the infra, such like a ship or the equipments, it's not easy to build up in the short time or make us within a short time. So I think the start points will be the communication with the papers who want to be experts of this kind of explorations. So, or the educations or the something like that is very important, I think. That is a start point, I think.
Okay, it's very nice answer. Okay, maybe we can have one or two last question for Mr. Park. Is there any from audience? And I'm also interested about how the seabed exploration and somehow later on could be also more to energy sustainability, where you shown as well. For example, the one in Norway and so on. So how is there any like your opinion for this energy sustainability from this seabed exploration, for example, in Asian country or something like that?
Oh, it's a tough questions, and I think I need more focus on that kind of questions and answers. But I think the Asian countries has a lot of chances to find hydrothermal deposit in their oceans. I mean, their easy zone, kind of exclusive zones. So I think there is a high possibility to find and explore. I mean, define and develop the seafloor resources. But the problem is, the who is first, learners to develop this kind of things, because this is not not yet developed now. So the first learners have some, they make some profit or they make some the actions, and then the second learners or the following learners can do easily. So in that times, I think the Asian countries has a lot of lots of chance to develop that kind of seafloor resources, I think.
Okay. Okay. Many thanks again for Mr. Park for the discussion, and I think our time is very limited. And now we can move to the is there any Pak Hansan? You have more question? Pak Hansan, Park, you raise your hand. Hello, Pak.
I did not. Yeah, sorry. Yeah, I need to press once more time. Yeah.
Okay.
Down
Okay.
hand. Yeah.
Okay. So thanks again to Mr. Sang Jun Park, and thank you also Pak Hansar Park for being here with us. And we will move to our next presenter, that is Jian Xiang Wang from Zhejiang University from China, with the title of Calcium Isotopic Proxies for Hydrothermal Activities in the Sediment Cores of Tianxiu Hydrothermal Field, Carlsberg Ridge. And the presentation will be play as video. But however, okay, so we will start the video.
Okay, fast. Thank you for giving me
Do we have? And is Kiang Wang is here in this breakout room?
Okay, first, thank you for giving me this opportunity to show.
Please wait for a moment.
Okay, first, thank you for giving me this opportunity to show our research topic. The topic is calcium isotopic proxy for hydrothermal activities in the sediment core of tensile hydrothermal field Casper Ridge. It's my content. Since the discovery of the first hydrothermal field, the seafloor hydrothermal process is a major control on heat flux under the under the chemical element of the ocean. The most hydrothermal activities are distributed along the mid-ocean ridge and have a significant impact on the ocean. Our research area is located in the Casper Ridge, the northwestern neighbor of the Indian Ocean Ridge. According to the previous study, tensile is controlled by the detachment fault, and it's an active field. In the hydrothermal field, and have been found out a group of the ultramafic rocks maxis section under the ultramafic rocks. And then, why we want to research it to discuss the scientific issues. The first one, the characteristics of the calcium isotope change indicate the history of the hydrothermal activity in the tensile, and compare with the traditional indicators of the hydrothermal activity. Calcium isotope has the advantage of indicating the hydrothermal activity, and it can prove a theoretical basis and a support for the global calcium cycle. So we do some. So in order to explore the characteristics of the sediment, we made performed some analysis, such as the scanning electron microscope. The sediment were mainly composed of the sulfide, such as pyrite and chalcopyrite, and some metal oxide. And the secondary sulfide, such as the cobalt and some biocarbonate and some altered automatic rocks such as the serpentine. And then the down-code distribution of element shows three types of elemental distribution. The first is basically unchanged, and another is S-types, and the last one is anti-S-type. Maybe it's the material source different, or the evolution of geochemical process result in this different characteristics. And we also compare with the characters of the else element with another and member. The tensor is show slight negative theorem anomaly is similar to the seawater, and show observe positive European anomaly is similar to the hydrothermal products such as the food and the sulfide. And then we also performed the pre-simple component analysis on the element and the calcium isotope of the tensile core sediment. Based on the observed analysis and the PCA, it is inferred that the material source basement includes the basalt and the automatic and the biogenic and the hydrothermal product. And then, in order to destination the source from the hydrothermal input and consider the basalt or automatic rocks in the hydrothermal field, we proposed the ternary diagram of element. The aluminium and the potassium is represent the basalt, and the magnesium represent the automatic rocks, and then the iron and manganese represent the hydrothermal composite. The background sediment posed close to the basalt sample from the study field indicate the background sediment is affected by the basalt, and the core sediment, as we can see, it has they have intermediate composition feature between the background and the serpentine and the bottom hydrothermal sediment. So it suggests the tensile core is a mixture of clastic basement material and background sediment and the hydrothermal product. And why? So why wants to use the calcium to discuss the tensile hydrothermal activity? According to the above analysis, the tensile sediment is mainly affected by the volcanic rocks and carbonate, and the sample value is between the bicarbonate and the bulk silicate earth. Under the previous study found that is no significant calcium isotopic fractionation occur between the hydrothermal fluid and the ocean crust. And when the hydrothermal calcite precipitation is hardly happens the isotopic fractionation. So we saw the mag oxide ratio with the calcium oxide model. When the x-axis values is 0, we get the bicarbonate calcium isotopic value. Under the water rock recreation process, the calcium isotopic fractionation hardly occurs. So we assume the value the hydrogen member isotope consists with the silicate earth. And then we throw the formula verify that the bicarbonate calcium isotope is controlled by the surrounding seawater temperature. The value is about 5 centigrade, which is close to the values of deep sea water. And then we throw the end-member mixture model calculation. The hydrothermal and bicarbonate calcium contributions in the sediment core. And as we can see, say the contribution rate a change with depths show the hydrothermal activity variety with time. The last one, why is the calcium isotope compared with we use the calcium isotope compared with the traditional hydrothermal activity index. The evolution trend evolution trend with time is consistent, but the calcium isotope has advantage of indication hydrothermal activity because in the hydrothermal activity process, the calcium isotope is not controlled by the redox, and it's hardly occur as a isotopic friction. And the last is primary conclusion and the future work. Potential sediments are mainly derived from hydrothermal input with biogenic under the trial composition influence, and because there is no isotopic fluctuation in the process of hydrothermal activity, therefore the calcium isotope composition is an effective tracer of the process of hydrothermal activity. And in the future work, because the isotope provide insight into the mechanism of the ocean material mantle cycle, therefore we want to use it to explore how hydrothermal activity affect the element cycle, and further improve the global calcium cycle. Okay, that's all. Thanks.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for committee to let us present our research in this international symposium. The title of our research is the growth rate comparison of Chema denticulatum cultivated with horizontal net and vertical net. This is two variant of our to cultivate seaweed in Eastern Indonesia. Me, myself, Maruf Kasim, and our team is Munawan and Roslaini. We are from Faculty of Fishery and Marine Science, Halolo University. And the corresponding of this research is me. You can email me if you have some question about this research. Okay, for the introductions of our research is, as we know, the Euchema denticulatum, mostly cultivated in Indonesia people. I mean that is in mostly if you looking at in the coastal area, they are cultivate Euchema, particularly Euchema cottoni of Capapicus alvarezi and Euchema denticulatum. This is the two really famous in the to cultivate seaweed in Eastern Indonesia, particularly in our study site. And this is because of the very simple method. They are using long line to cultivate Euchema and just put it in the line and then hang it in the ocean. After 45 days, they can cultivate it and dry it and they get the money. That is very simple method, very simple method. And mostly the coastal community make to cultivate the seaweed for a source of income of them. So that's why mostly they are using for get some money for the daily activity. And also this is very simple method, and then low infestations. They are just using the line and then the buoyants from the used bottle plastic, and that is very simple and very cheaper infestations for cultivate Euchema particular. And farmers mostly using long line. Long line is very famous method to cultivate Euchema seaweed, to cultivate seaweed mostly in Eastern Indonesia. And yeah, because of this is very simple method, and then this is easy money to get after 45 days. So this is very mostly activity in the coastal area in eastern Indonesia. If you're looking at in the coastal area, village coastal area, you can if they are near the ocean, then you can see a lot of people cultivate seaweed just the front of their area or the front of the village. And however, they are using the used bottle plastic, and then sometimes it's really very not good looking just the front of the village. Sometimes you are looking a lot of garbage buoyant on the surface of the water, and then this is aside not good looking, it's satiating. I mean that is it's not so good if you look at just the front of their village. A lot of garbage floating on the near the village. And another problem they are faced is some seaweed cannot be grow well because of the seed. And then another problem that is very what mostly appears in the location. So that's why they are sometimes cannot be get money from the seaweed activity because the activity cannot be grow well. And another problem is this grazing activity by some fish like siganid. This grazing activity occurs every time. I mean, that is not only like medicine together from the doctor, but I mean, that is every time after they are put it seaweed in the ocean, then suddenly the siganid will graze the seaweed. And from our research, this is really decreased up to 60% from the total harvesting of the seaweed from the farmer. So this is a really serious problem faced of mostly farmers in Eastern Indonesia particular. And our research method is we are doing the research in the Bau-Bau coastal area. This is the name of Lakeba coastal area. Locations, this is most of the people cultivate a seaweed for their activity. And then this is locations in Southeast Sulawesi. Southeast Sulawesi is one of the Indonesian Seaweed Development Center. I mean, that is mostly people in the Southeast Sulawesi develop seaweed cultivations. So that's why we are doing this research in these locations. And this is if our study site, this is in Indonesia, and in Southeast Sulawesi, we have just 120 kilometers from our university. This is the Bau-Bau city, and then just near the front of the Bau-Bau city, we are cultivate or we are done our research in here. And mostly the area in this the area is very good to seaweed cultivations because the locations is very not have a wave big wave, but several low current, and then the very bright location. So that's why this is very good for seaweed cultivations. And this is our method. We are using two kind of the method, actually vertical net and horizontal net. This is we are already patent for this, and we already registered for the patent of this vertical net. Vertical net is the we are using the water column for the seaweed cultivations, and then this is the horizontal net we call horinet. We are already registered also, and this is a very simple method. Just put it on the seaweed to avoid the siganid grazing or the sea turtle grazing. So this is very good method to protect seaweed from various grazing from the herbivores. And then our data analysis, we are trying to analyze the specific growth rate obtained by determine the weighting of the wet weight of the seaweed seedling just for 45 days, because every week we have to calculate, and we analyze using Luhan and Solista, and analyzes we are also try to make the correlations between the specific growth rate and the water quality to see the relevancy of the water quality on Capapicus and Euchema denticulatum. Okay, this is the result. Thank you very much for the result. This is the difference of horizontal net and vertical net from the specific growth rate. They are really good because sometimes the specific growth rate is lower than 4 or lower than 3. But during our research, we found that the specific growth rate is up to the horizontal net up to 9, and then vertical net is almost 7.8. So in that is in the first day, in the first week for during our research. But you know that is the specific growth is mostly it will be decreased during the day. And then, but the mostly average of this specific growth rate is a little bit high compared than long line one. I mean, there's even the horizontal net and then vertical net, the average of the specific growth rate is 6.5 and then 4.2. And this is the specific growth rate of our research. This with the standard deviation, we try to looking at the horizontal net a little bit higher than vertical net. 44. The average in during all of our research is 4.7, and the vertical net is 3.6. Mostly this specific growth rate is high compared than long line one, because the long line one sometimes we are find below than 3. And this is the different let's indicated for this different significant. And then we are trying to also looking at the wet weight of the Euchema denticulatum during 45 days. So from 20 gram, we are after 45 days, we are found 145 gram for horizontal net, and vertical net from 20 gram, we are found 91 gram. This is the comparison from the Euchema denticulatum using vertical net and horizontal net. And the average, we are found a little bit high from horizontal net to vertical net. Actually, this is the different from total growth during our research. Then we are found that the average of horizontal is the little bit high compared than vertical net. And we also try to analyze the different from the talus of the peak, middle, and the base. And then we have found that from the total 10 gram, that is the base one is the base talus in the in the center talus, that is a little bit high compared than middle one and peak one. And this is also found the water quality. pH, salinity, temperature, brightness, current speed, and then depth, and nitrate, and phosphate. We are compared to another research, another area that we found that is not really different from our research. So that's why the water quality of this area is good, then is really useful. That is really good for seaweed cultivation area. And this is the analysis we are trying to analyze the correlations between the horizontal net and vertical net and water quality, that we found that current velocity and salinity is really have a significant from the horizontal net, and also the vertical net is current velocity also. And for the conclusions of our research is the Euchema denticulatum using the horinet it a little bit high compared than vertical net. I mean, that is we are found the high one is 9.80% per day, and then vertical net is 7.89% per day. And then the total growth that is from 20 gram, it become 112 gram. And then for vertical net, we are found net average is 97.5 gram. This is based on our research that the correlation test environmental have significant to specific growth rate. And this is our research in the area that is Thank you very much. We are grateful for Ministry Research of Higher Education and then Republic of Indonesia. I mean, that is now Dikbud. And also gratitude for Fishery Laboratory, Faculty of Fishery Marine Science, and also LPPM Honolulu University. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Hello everyone. Assalamualaikum warahmatullahi wabarakatuh and good afternoon. My name is Zainul Hidayah and today I'm going to present my article. The title of the article is Modeling Sea Surface Current in the Eastern Coast of Bawean Island, East Java Province. So my presentation will be divided into 4 sections.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for committee to let us present our research in this international.
Hello everyone. Assalamualaikum warahmatullahi wabarakatuh and good afternoon. My name is Zainul Hidayah and today I'm going to Hello everyone. Assalamualaikum warahmatullahi wabarakatuh and good afternoon. My name is Zainul Hidayah and today I'm going to present my article. The title of the article is Modeling Sea Surface Current in the Eastern Coast of Bawean Island, East Java Province. So my presentation will be divided into 4 sections. The first one is introduction. The second one is methods, and in the third one, we are going to talk about results and discussion, and finally, the conclusions. First of all, I would like to explain about the background of this study. So, the East Java province consists of about 438 islands. Most of them are small islands with coral reef ecosystems. However, they are lack of documentation. One of the islands is the Bawean Island. According to the RZWP 3K document, this island has been promoted as a marine conservation area. Therefore, the availability of data related to the island is very important. As we all know, the interaction between the oceans and the atmosphere cause variations in the condition of oceanographic parameters, for example, currents and waves. Understanding the characteristic of environmental parameter is very important, especially for the development of marine infrastructure or other related development of coastal and small island area. This study applied numerical modeling to simulate the ocean currents on the surface. This method has been widely used to provide information about the movement of water masses in their effects on environmental processes. So, the objective of this research is to map the profile of benthic environment of Bawean Island and to study the characteristic of oceanographic parameters, especially the surface currents in the eastern part or eastern coast of Bawean Island. Now we are talking about the methodology. So this study was conducted in Bawean Island. This island located about 80 kilometers north of East Java mainland in the middle of Java Sea. It takes about 6 to 8 hours to reach the island from the Gresik harbor. Field data collection was conducted, started from the 1st December of 2020. We use ADCP to measure the current speed and direction. The bathymetric data was obtained from the Indonesian Navy Hydrographic Center. The bathymetric map was used to create a domain in the form of flexible mesh. This is very important for the modeling processes. During the field observation, we were also collected hourly tide, wind, and speed directions from the year 2019 to 2020, obtained from the Meteorology, Climatology, and Geophysics Agency of Sangkapura Port. These data were also the main input for the sea surface current modeling. results and discussion. According to the Indonesian Navy bathymetric map, the maximum depth of Bawean Island range from 60 to 65 meters. Shallow water covered with sand are located to the east and south of the island with a depth ranging from 5 to 20 meters. The rise of seabed structure, especially in the west and the east side of the island, form small hilly around the mainland. Furthermore, from the hourly tide data, we can see that the tidal type of the study area was diurnal, with mean sea level approximately 1.05 meter. The tidal condition in the East Java are the results of the interaction between seawater masses coming from the Pacific and Indian Oceans. Due to this complex interaction and different geographical conditions, there is a variation of tidal types in the coastal area of North Java. For example, some area has diurnal tide type, whereas the other have mixed tide prevailing diurnal type. The ADCP data was used to validate the simulation results. Basically, we compare the ADCP results and the simulation results, and then we calculate the root mean square error of the observation. There are two observation points during the study. Each of them was measured for 5 days. Based on the comparison result, the RMSA values were ranged from 0.21 to 0.24. From the results, we can understand that the smaller RMS value, the closer the predicted and observed value. Therefore, we can argue that the model in this study was close to the reality. Another study using the same comparison was conducted in Carey Island of Malaysia, resulted in the smaller RMS values from 0.13 and 0.11. The other results conducted in the coast of Muara Karang and Banten Bay with the RMSA results around 0.19 and 0.12. The simulation results can be seen from this graph. So we can see the results of modeling the speed and directions was carried out during the west monsoon from December to February and the first transitional monsoon from March to May. In the west monsoon simulation result, it showed that the dominant surface current in the eastern part of Bawean Island moved from north to south and was slightly deflected to the southwest. The maximum current speed, based on the simulation, reached about 0.07 meter per second, while the minimum was about 0.005 minutes per second. The next result was simulation during the first transitional season. It showed that there is a change in the direction of surface current. In this period, the currents move from the south to the north and the northeast. The maximum current speed was higher, about 0.17 minutes per second, and the minimum was 0.03 minutes per second. Based on the modeling results, we can see that the dominant surface currents direction flowing from the north to south in the west monsoon and vice versa during the first transitional season. The current velocity or the current speed in the study area was classified as low to moderate because the average was less than 0.5 meter per second. The morphology of the shallow water in the island was dominated by coral reefs. It affects the vertical distribution of current velocity. The movement of water mass will be experienced a heavy friction with the seabed, resulting in the speed reduction of the current. The study also showed that the weak sea surface current in the study area were predicted as the results of ecological role of coral reef in spreading and weakening the strength of currents flowing into the area. Finally, information regarding surface current is important for further use, especially for a small island with great potential such as the Bawean Island. The information about surface current can be used as to support the development of marine aquaculture and the development of marine infrastructure. For example, the floating net cage, and also the information of surface current can be used to calculate the load of resulting fish feed waste from the floating net cage, as it has been explained from the previous research. The current speed and direction can also be used as the main consideration in determining the suitability status of marine tourism activities in the small island, particularly for swimming, snorkeling, and diving activities. So, based on the results of this study, we can conclude that this study has demonstrated the combination of field data collection and hydrodynamic modeling to examine the movement pattern of sea surface current in the eastern coast of Bawean Island. The simulation was conducted in the west monsoon and the first transition season. The simulation showed that the current speed in the study area was low, less than 0.5 meter per second. The dominant surface current's direction was flowing from north to south in the west monsoon and from south to north in the first transitional season. The current speed pattern of the simulation and field data measurement were not significantly different. That will be all. Thank you for your time, and I expect there's a discussion after this presentation. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Greetings to all committees and participants of the 2021 MSAT Conference Management System. My name is Sharifah Fauzah, Earth Science student, Bandung Institute of Technology. Today, I will present my paper entitled Three-Dimensional Numerical Modeling of Tidal Current in Balikpapan Bay using the Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum. Assalamualaikum warahmatullahi wabarakatuh. Greetings to all committees and participants of the 2021 MSAT Conference Management System. My name is Sharifah Fauzah, Earth Science student, Bandung Institute of Technology. Assalamualaikum warahmatullahi wabarakatuh. Greetings to all committees and participants of the 2021 MSAT Conference Management System. My name is Sharifah Fauzah, Earth Science student, Bandung Institute of Technology. Today, I will present my paper entitled Three-Dimensional Numerical Modeling of Tidal Current in Balikpapan Bay using Delft3D. The following is a summary of my presentation consisting of introduction, materials and method, results and discussion, and conclusion. First, I will explain about this research background. Balikpapan is located on the east coast of Kalimantan Island, directly adjacent to the Makassar Strait, and function as a shipping port city. Balikpapan Bay is also included in the new capital area of Indonesia, which results in industrial, residential, commercial, and other activities that will increase very rapidly. The hydrodynamic condition of the water is essential to know because it dramatically influences the process that occur. The hydrodynamic condition of the water is influenced by several factors, including coastal morphology, bathymetry, river runoff, air mass effect, and tides. Research on hydrodynamic modeling in Balikpapan Bay has been carried out, including the study of hydrodynamic models to determine tidal front pattern using co-phase and co-range maps, two-dimensional hydrodynamic modeling with a focus on the domain area in the bay, and the study of 3D tidal flow pattern in Balikpapan Bay using MOHIT. Then, in this research, I will analyze the hydrodynamic pattern of Balikpapan Bay with a more comprehensive three-dimensional domain area using the Delft3D. This study aims to simulate hydrodynamic in the Bay of Balikpapan with tidal force and discharge. Analysis of bottom currents, bed shear stress, co-phase, and currents was carried out to understand the dynamic of Balikpapan Bay area. This study is located in Balikpapan Bay, East Kalimantan, Indonesia. The model domain includes the water of Balikpapan Bay and a small part of the Makassar Strait. Here are the dimensions of Balikpapan Bay. And then this is the bathymetry of the Balikpapan Bay. And the model used rectangular domain grid with uniform dx and dy. This model has 3 depth layers with sigma coordinate. In addition, the tidal input used 8 components from Topex 9 and input for river discharge is from Erosion and Sedimentation Working Group 2002. Moreover, the location here are the location for observation point and verification point, as you can see here. And this is for model verification. We use coefficient correlation, scale, mean average percentage error, and root mean square error. And then the initial value for elevation and current velocity are 0. And here are the time settings and physical parameters. Next, the equation used in this model is the hydrodynamic equation. Hydrodynamic equations are divided into continuity equation and momentum equation. Here are the equation of momentum on the x-axis and y-axis. There are 4 boundary conditions used in the model. It's open lateral boundary, closed lateral boundary, bottom boundary condition, and surface boundary condition. The flow chart of this research is like you can see here. And then results and discussion. Verification of tidal elevation is done by comparing model data with geospatial information against sea data. Verification shows good results, indicates by the value of correlation, RMSE, and scale, like as you can see in this table. And for current velocity verification is done by overlaying the model data with digitized observation data by Nurjaya et al. 2018. The results shows a good results, which means it's similar like observation data, like you can see in this table. The propagation of tidal waves in Balikpapan Bay is carried out by describing the currents and co-phase maps of the M2, S2, K1, and O1 component. The following is a map of the currents and co-phase of the M2 component. The tidal propagation of M2 component from point B at the mouth of the bay to the point C takes to 21.7 minutes. And this is currents and co-phase for S2. Propagation of tidal component for S2 from point B to point C takes 10 minutes. And it's for K1. It takes 9.97 minutes. And last, it's for O1 component. And for K1 component. For O1 component, I'm sorry. It takes 10.75 minutes. The following is the spatial result of current factor for depth average velocity. Spring tide condition were sampled on February 19, 20, and 19. The current velocity at the lowest low tide has a low speed. When the flood tide condition, the current velocity has the highest value. During the high tide, the current speed seems calm. Then at the ebb tide condition, the current speed increased again. In this neap tide condition, it was chosen on February 13, 20, and 19. When the high tide condition, the current velocity is seen to be higher outside of the bay. During ebb tide, the current velocity in the bay ranged from 0 until 0.5 meter per second. When the low tide condition, the current velocity in the bay tends to very small, then this is for flood tide condition. In these studies, the analysis of near-bed currents at a depth of 1 meter above the bottom of the waters aims to see how much current speed can affect the state of the seabed. Here are the conditions when the low tide condition and when the flood tide condition. Here are when the high tide and the ebb tide. The most significant current velocity occurs when the ebb tide conditions. When sampling the same tidal condition during neap tide, it is seen that the current velocity at the bottom has a shorter current factor's length, which indicates a smaller magnitude. Here are the conditions when the high tide and when the ebb tide. And then it's for low tide and flood tide. The following is the condition of the sea level elevation compared to the magnitude of the current velocity and the magnitude of the bed shear stress at 4 observation points. The fluctuation between the magnitude of the current velocity and the bed shear stress are similar, where when the magnitude of the current velocity increases, the magnitude of the bed shear stress increases. The magnitude of bed shear stress is significant when the spring tide conditions. Similar fluctuations occur at all observation data. It's for point A, point B, point C, and point D. When compared with the 4 observation point D at the mouth of the bay has the most significant magnitude of the bed stress, and point A in the upstream of the bay is the opposite. This is due to the large magnitude of the high current velocity around the mouth of the bay by deeper bathymetry. Knowledge of the bed stress is required to relate sediment distribution and hydrodynamics condition. If the magnitude of the bed stress exceeds the magnitude of the critical shear stress, there will be erosion by the current at the bottom. According to Dufois et al. 2008, the critical shear stress in the cohesive region range from 0.01 until 0.06 Newton per square meter. So more or less, the area starting from the yellow color is considered to have occurred erosion. Here are the low tide condition during spring tide. This is when flood tide. And this is special plot when the high tide, and this is when the ebb tide condition. And this is the high tide condition when neap tide. This is when ebb tide. This is when low tide conditions, and last this is flood tide condition during neap tide. Okay, next conclusions. Then the conclusions of this study includes first, the simulation results of the hydrodynamic model for the sea level elevation value can represent the condition of the waters in Balikpapan Bay. And second, the currents maps show the amplitude values of M2 and S2 component dominating the tides in Balikpapan Bay by 65.3%. And then M2 component in Balikpapan Bay, we can see the pace propagation from mouth to the head from the M2 and S2. For M2 component, it takes 22.77 minutes, and for S2 component, it takes about 11 minutes. Significant current velocity is at flood tide during spring tide, and the highest speed is about 1.62 meter per second. And last, the magnitude of current velocity determines the value of bed stress magnitude. Okay, the observation point at the mouth of the Bay Balikpapan Bay at the point D has the most significant bed stress. This is the acknowledgement for this research, and thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I would like to say thank you for your coming in my presentation. I'm Alvin Adibaskoro from Bandung Institute of Technology and Geodesy and Geometric Engineering Department. I want to explain about spatial modeling of sediment explored with rainfall variability scenario in Payasangan Watershed Aceh Province. My background research is in 2007, the Intergovernmental Panel on Climate Change (IPCC) published a fourth assessment report stating that coastal areas are particularly vulnerable to erosion and sea level rise as a result of climate change. Rainfall is one of the climatic elements that can cause erosion. Meanwhile, watershed and coastal sedimentation is causing changes in environmental appearance. By UNCLOS, there is a change in the baseline due to water sedimentation, coastal erosion, and sea level rise can claim the maritime zone. My research objectives are determining the correlation between rainfall variability and sediment explored in Payasangan Watershed Aceh Province, and calculate the total export of sediment in the outlet of the Payasangan Watershed Aceh Province in each modeling year. The benefits are determining the vulnerability of erosion effect arise in the Payasangan watershed and exporting knowledge in the future research to analyze the impact coastal dynamic on maritime boundaries. The study area, the criteria for a suitable location based on objective and benefit in Payasangan watershed and the coastal along the estuary of Payasangan River Aceh Province. Consideration by land in the coastal area of Muara Sungai Payasangan intersect with the normal baseline. There have been many erosion modeling in Java and BMKG climate observation data available around the study area as validation of global climate data. The reset will needed the data required are rainfall data from Santa degrees and Maluku Saleh Meteorological Station observation data for evaluate the global climate data used in modeling, and then dam hydroseed data with a resolution of 90 meter derived from HRTM, and then soil type data from soil grid refer to the classification WRB 2006, which has a spatial resolution of 250 meter with overall accuracy of 70%. And the last is land cover data. Land cover data from the LCCS with a spatial resolution of 300 meter, and the data used in 2018 with overall accuracy of 70.82%. The flowchart can be seen in the right side. Next is revised universal soil loss equation. From this picture can be seen that the erosion that occur is influenced by erosivity, soil erodibility, land cover, slope and length, and conservation factor. Air factor, rainfall effect are erosion plan and supplier of water flow volume as a medium of carrying eroded in material. Then K factor, the resilience of soil structure at the time of receiving the influence of erosion of rainfall and water runoff depend on infiltration, permeability, and soil capacity in water holding. Then C factor, plant factor and soil management on land cover are useful to determine the vulnerability of erosion rate. Land cover as watershed defense. And then LS factor. LS factor is the dominant factor of dust topography or watershed topography. It is because the lake affect erosion based on rainfall intensity response, and the slope affect the discharge rate of surface flow. And the last is P factor. It is a factor of human action in soil conservation. P we can derive from the slope value of land by Sharma et al. And then erosion hazard classification. Erosion level class analysis aim to determine the rate of erosion in a watershed area. Classification based on Indonesian Ministry of Forestry in 1998. And then SDR. SDR is comparison between sediment export in watershed outlet and eroded sediment mass. SDR calculated by processing of 300 watershed by Vanoni. And then calculation of sediment yield or total sediment export. Total export sediment export can be done by calculating by erosion rate and SDR value. Determination of erosion rate based on sediment value export to watershed outlet is classified as by Mulyanto by normal, critical erosion, and supercritical erosion. And the last is model comparison. The modeling results were compared with similar modeling done on other watersheds with relatively similar characteristics. Then the result 3.1 is rainfall variability scenario. From this picture and from this table, we know about Persangan watershed has the characteristic of dry season rainfall will decrease, while the rainy season will increase. But not in the period of 2005, which has the least annual rainfall. 3.2 Global Climate Data Evaluation. Maluku Saleh Meteorological Station daily observation data for 2015 and 2018 with the selection based on its location close to the study area. From this table and graphic, we can get information that the global data from the Santa Clara University can be used as data for erosion rate modeling by Russell method as a calculation of rainfall erosive factor that require annual rainfall data in Persangan watershed as a research site. Because the percentage rate of difference between global climate data and Maluku Saleh Meteorological Station of 26 and 17%. Then erosion rate. The erosion rate can be seen in this table. In general, high erosion rate values are generally located in area with steep topography with a slope of more than 25%. Soil type dominated by andosol and rainfall ranging from 2,300 mm per year to 2,800 mm per year during the modeling years range used by Indonesia Ministry of Forestry in 1998. Classification of erosion hazard level in general Persangan watershed has the potential for mild erosion with the average rate of erosion occurring in the range of 15 to 60 tons per hectare per year in each modeling year. Point 3.4 correlation of relation between rainfall variability to erosion rate. Because the rate of sediment export is proportional to the rate of erosion, the correlation between climate change and sediment export rate can be calculated from the correlation of climate change to erosion rate. From the calculate and this table, we can get the information that rainfall has a very strong level of their relationship to changes in erosion rate with the value of correlation coefficient close to 1. Then we can know total sediment export from calculate by erosion rate and SDR in this table. And the last is comparison of modeling result with previous reset. The model comparison is done by comparing the total result of sediment export in Pasangan watershed with other watershed with characteristic and areas that don't differ much. Based on the data compared the total export of sediment between Pasangan watershed and other watershed obtain information that the modeling results are said to be quite good because it is still in the same order range with range of between 1 to 10 million tons per year. The last is conclusion. The correlation coefficient between climate change scenarios and sediment export rate is close to 1. Information obtained that precipitation has a very strong direct level of relationship to changes in erosion rate with a correlation coefficient value approaching 1. 2. Based on the spatial distribution of sediment export rate, in general, Pasangan watershed falls into the category of normal based on Mulyanto 2006. And 3. This research has a useful output as a consideration for the governmental in the development of adoption strategies that take into account rainfall variability as well as watershed and coastal dynamic. While in the academic field, this result can be used as knowledge to support future research to analyze the impact of coastal dynamic on regional boundaries. And the question are to test the quality of the model, field validation activity are needed to verify input data and result. And then better use of resolution quality data is required to improve the accuracy of erosion rate estimation. And the last is SDR estimation is better based on the representation of the cycle process of sediment transport on the slope of the watershed and the river channel system as subsystem of watershed storage. Thank you for your attention.
Assalamualaikum wabarakatuh. Thank you for coming to this presentation. Let me introduce myself. My name is warahmatullahi wabarakatuh. Thank you for coming to this presentation. Let me introduce myself. My name is Narziusan Alfandi. In this opportunity, I would like to present our research with the title The Effect of Change in Land Cover on Total Sediment Yield in Pasangan Watershed, Aceh Province. The outline of this presentation is divided into 4 sections. First, introduction. Second, methods and data. Third, results and discussion. And fourth, conclusion. The first part of the introduction contains the background, purpose, and study area of this research. Background. Watershed is an area above or higher than a river whose topographical boundary causes water to flow into the same river. River water flow carries a variety of particles. One of them is sedimentary particles from the erosion process. Sediment is a collection of particles derived from the erosion process from a place that then settles or floats in the catchment area. Sediment carried by the river has the potential to cause swallowing of rivers and estuary area and affect water quality. The erosion process is influenced by several factors. One of them is the type of land cover. The type of land cover determines the level of soil protection from erosion because of the speed of rainwater. The speed of rainwater will slow down when it hits vegetation or canopy before it hits the ground so that the erosion generation force is reduced. From the background that has been mentioned, the purpose of this research is the first to detect change in land cover that occurred during 4 years of observation. Second, estimate the rate of erosion with variation in land cover. Third, calculate the SGR value and the total sediment yield. Fourth, identify the effect of change in land cover on change in the total sediment yield. Furthermore, the research study area is in Pasangan Watershed, Aceh Province. Pasangan Watershed has an upstream river that is in a mountainous area and crosses 4 districts until finally reach the coast of Biren district, which intersect with the normal baseline. The scope of this study is divided into 3 scopes. First, spatial scope. This research was conducted in Pasangan Watershed, Aceh Province. Second, temporal scope. Estimated erosion rate is in 1995, 2005, 2015, and 2018. Third, conceptual scopes. In the study conducted erosion rate modeling with Russell method and SGR calculation as a function of watershed area focused on land cover change scheme. The data used in this study consisted of digital elevation model, land cover type data, soil type data, and rainfall data. The methodology of this study is divided into 4 main parts. The first is the detection of change in land cover, then the calculation of erosion rate, the calculation of SGR, and the last calculation of sediment export rate and the total sediment yield. Detection of change in land cover. Change in land cover significantly affect sediment export to river because of change in surface roughness, water to soil infiltration rates, and hydraulic links into watersheds. In this study, change in land cover were detected from the large percentage change in the area of each type of land cover. The rate of erosion represents the rate at which the mass of soil particles or rocks that are lifted from their source is the result of a force. The erosion rate in this study was calculated using Reinhardt's Russell equation, where erosion rate is influenced by annual rainfall erosive factor, soil type erodibility factor, slope length and slope factor, and land conservation practice. Rainfall acts as a splash erosion generator and supplier of water flow volume. Soil type affects soil sensitivity to erosion due to soil texture and infiltration capacity. Flow length, slope, and land conservation practice affect the speed of surface water flow. Sediment delivery ratio is a comparison of the number of sedimentary particles that are transported out of the watershed system to the amount of particle mass that is eroded throughout the watershed. The SDR value is inversely proportional to the area of the watershed. The wider a watershed, the smaller the SDR value and vice versa. The smaller the SDR value if the area of the watershed is wider, influenced by travel time of the eroded particle to the watershed outlet due to the length of the flow that must be traveled so that the particles are heavily deposited in the water flow. The SDR value in this study was calculated based on the equation from Vanoni, where A is the area of a watershed in square kilometer. The rate of erosion only states the number of soil particles that are detached from the source. The eroded soil particles are partially decomposed and some are carried away by the flow of water. Sediment particles that are carried out of the water system are called sediment yields. The total sediment yield will usually be much smaller than the amount of particles mass erosion. The sediment export rate is calculated from the erosion rate and SDR value using the following equation. Here's the table of change in the percentage of land cover. A significant change in land cover in the period 1995 to 2005 was a decrease in the percentage of land cover type with ID 30 of 1.74%. From 2005 to 2015 was a decrease in the percentage of land cover type with ID 50 of 3.66%. In the period 2015 to 2018 is a percentage decrease of the type of land cover with ID 50 of 1.85%. Here's a graph of the change in the percentage of land cover. Here to the spread of erosion rate in Pasangan watershed. From the map, fairy-like erosion level dominate in Pasangan watershed. Here's a table of the area of each class of erosion rate. Class division of erosion rate based on erosion hazard level from Ministry of Environment and Forestry. From the table of area and percentage, the Pasangan watershed is dominated by a fairy-like erosion rate with percentage of more than 60%. Here's a table of the average rate of erosion and the amount of erosion. From the average rate of erosion, watersheds are included in the low erosion rate according to the class division of the Ministry of Environment and Forestry, where from 1995 to 2018 continues to change as in the following slide. Next for SDR and sediment export rate. With the area of the Pasangan watershed reaching 2,252 square kilometer and SDR value of 0.18. With the SDR value, the sediment yield is obtained as in the following slide. To test the modeling results, it is necessary to make a comparison between the modeling results and the result of existing research. From the tables and comparison charts, it can be concluded that the modeling results are good enough because it is in the same order of 1 million tons, even though the watershed has a smaller amount of sediment yield than the comparison watershed. This can be due to difference in the characteristic of the comparison watershed. Calculation of correlation coefficient and coefficient of determination is performed that to the relationship of land cover change with change in the total sediment yield. The calculation result as listed in the table obtain a correlation coefficient of 0.9987, while the linear regression result obtain a coefficient of determination or R-square of 0.9978. The result of correlation coefficient and determination coefficient is interpreted as if the change that occur in the land cover will affect the total sediment yield. From the result and discussion can be drawn conclusion. First, land cover changes were detected in 3 periods, with the largest change during in the period 2005 until 2015 on the type of land cover with ID 5T, which decreased by 3.66%. Second, the rate of erosion in Pasangan watershed is in like erosion level, with an average erosion rate in 1995 it was 26.715, in 2005 it was 26.886, in 2015 26.771. Third, obtain SGF value in Pasangan watershed of 0.18, and the total sediment yield in 1995 it was 1,083,000 tons. In 2005 it was 1,090,000 tons. In 2015 it was 1,011,000 tons. In 2018 it was 1,085,000 tons. And fourth, change in land cover effect change in the total sediment yield indicated by a correlation coefficient of 0.9989 and a determinant coefficient of 0.9979. It's the end of my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Nazrin, for your presentation. So it's almost similar to the previous presentation. I mean the area of the research. The difference is only the relation between erosion rate and sediment, right? Before we're talking about the rainfall and erosion. So, and in this research, it's showing that the function of the watershed area is really significantly changes through the years for the erosion rate. So maybe we can continue to the discussion session. Is there any question from the audience? Please raise your hand. I have question to Nazrin. So as I mentioned before, so you said that the function of the watershed really important to the erosion rate. So how close, I mean, the relation between the two? Can you explain? Is Nazrin here?
Sorry, Miss. Nazri.
Okay.
Here, Nazri has bad signal in his home. Home.
Okay. Because before I saw him in the list, but okay, so it's okay. Yeah. So as I mentioned before, that the research of Nazrin is almost similar to the Alvin presentation, but it's different with different focus. Where the focus is relate the erosion rate to the function of the watershed area. So I think this mini session is almost complete. I mean, we have all the oral presenters performing their presentation. I want to remind you again to submit your list attendees or daftar hadir for those who haven't submit the list of attendee. And if there is no more comment or question, we could move to the main room before the closing for the day 1, and we will back again tomorrow at 8 a.m. So hereby me as the moderator thanking you for participating in this mini session, and I'm really sorry if there is inconvenience issue coming from our side. So thank you again for joining, and I'll see you in the main room, and also see you in tomorrow at 8 p.m. Thank you.
Recording in Indonesia.
Institut Teknologi Bandung is an adaptive learning organization. In our over 100-year journey, ITB has a long standing as the leader in advancing science, technology, art, and social and humanities as well. ITB is striving to play a significant role in solving Indonesia's challenges while improving its capacity to compete globally. The alumni are our pride, who continue to share our values and significant contribution to the nation's development. To continue our tradition, we will always preserve a campus with academic atmosphere that is open to new ideas and experiences,